Hi, my name's Tom Benson. I'm an aerospace engineer at the NASA Glenn Research Center in Cleveland, Ohio, and we're coming to you live here at Edgewater Park. Edgewater Park is about a mile west of downtown Cleveland, and we're here today to see something that happens twice in everyone's lifetime, but this will be the last time. We're talking about the transit of Venus. Venus is going to be passing across the face of the sun. We'll be watching this event here live in Cleveland for the next 2 hours. We're going to have some live music behind us, it sounds like. We're going to have a lot of fun with this. There's a historical context to the transit of Venus. And to cover that historical context, we've actually brought a person out here to Cleveland from the National Air and Space Museum in Washington, D.C. This is Steve Williams. And Steve, you came out here. Welcome to Cleveland.
Thank you very much, Tom. I'm glad to be here, enjoying the music and the sun.
Yeah, we've got the sun out finally. It's going to be kind of interesting.
So come on down and check it out.
Right. And we need the sun, don't we?
We do. And Tom's absolutely right. This has been a historically important event over the years. The first time it was ever seen by anyone was in 1639, and they are occurring in pairs, 8 years apart, with about 105 or 120 years or so between the pairs. This is the last one in our lifetimes.
When's the next one?
The next one's in 2117. You do the math. You know how old you are.
Okay.
And that one won't be favorably placed for us here in the United States. You've got to wait till 2125 for that. So enjoy this one while you can.
Yeah, and if you get a chance, we want you to go outside and take a look at it. But we want to tell you, and we're going to tell you over and over again while we're broadcasting here, be very, very careful. This is just like when we had that annular eclipse of the sun a couple of months back. And I'm sure you've seen the warnings. Don't look at the sun with an unaided eye, okay? There's ways to look at the sun. We'll be talking about that and how to protect yourself. But we want you to get out and take a look at it. It's going to begin in about a half hour.
Yes.
And it's going to take a while, won't it?
It'll last almost 7 hours.
7 hours.
Yeah, 6 hours and 40-something minutes, depending exactly on where you are. But it's going to be a long-term event and very exciting just because of its rarity. It's also been important, as we were saying, from a historical point of view. The 1760s transits were used to make an attempt to understand how big the solar system is in terms of absolute miles. The calculations didn't work out as well as they hoped, but they did learn that Venus has a dense atmosphere, so it was an important set of discoveries just the same. They improved the measurements in the 1774 and the 1874 and 1882, I get the numbers mixed up, transits, and of course now we can use other techniques for determining distance, but we're still doing real science even on this transit that is difficult to do other ways. So it's an exciting time for that. It's also a 400-year tradition that goes back to those early transits. In fact, it goes back to the very first telescopes of being able to look at things like the sun, see spots or see objects like Venus in transit and figure out just what it is, be able to predict those things and understand them better. And that goes all the way through to today with the Kepler spacecraft presently in operation that's looking at a detailed area of the sky and seeing minute dips in light on some of the stars that correspond to transits of planets, other planets orbiting other stars passing in front of them, and we found almost 700 exoplanets that way. So there's a long tradition here conceptually and observationally, and it's very exciting to be part of it.
So to see what's going to happen today actually is that between the Earth and the Sun, Venus is going to pass.
Correct.
Now, why don't we get to see that every year or every 8 months? Or
That's right. Well, Venus being close to the sun goes faster around the sun than the Earth does.
Okay.
So it catches up with and passes us on a regular basis. The issue is the plane that Venus orbits in and the plane that the Earth orbits in are slightly offset. So it's not enough to just have Venus come by and pass it. It has to pass us at just the right time when we're at the one of 2 points where the orbits coincide, the nodes of the orbits, and that is why it's so rare.
So then when we're not at that condition, Venus will pass over the sun,
Slightly
or
higher,
below
slightly
the sun.
below, and just won't be seen in silhouette.
Okay. And when it's passing over or below, or when it's in any kind of orientation, we always kind of see Venus near the sun. It's the
That's
morning
right.
star, or
That's
it's
right.
the evening star, and it never gets too far away from the sun.
That's
just
true.
because of the geometry.
That's right. That's right. And Mercury, much less so because it's closer to the sun. Venus can never be more than about 40 degrees from the sun. And in fact, that's how, before the transits of 1760s, the astronomers were able to figure out from those angles how big the solar system was, at least the inner part, but only in terms of the Earth-Sun distance. They couldn't put absolute miles on it.
Okay.
They had is it close and close together, or is it far away and far apart problem. They couldn't resolve that.
Okay.
But by seeing the transit from different places on Earth, the position of Venus on the sun and the time it would take for Venus to cross the sun slightly different. And by making those observations in detail, it was possible to calculate the Venus.
So any place that you are on Earth, when you look up to see Venus pass across the sun, it'll be at a
very slightly different
location.
Yeah, very slightly.
So then if you wanted to do a scientific study of that, you'd want to see it from lots of places on Earth.
That's right. And in the olden days, that meant people had to travel literally to the ends of the Earth, and in the 1760s, that wasn't easy to do. There are stories about hapless expeditioners that had all kinds of trouble. But these days, there's an app for that. Okay, there is an app that you can download from either the NASA site or venustransit.org that you click when Venus starts to transit or leaves the sun, and your smartphone or your device knows where you are. It uploads all that data. It's automatically collated, and they'll get a result we all will share in to make the same measurements that Captain Cook wanted to.
I know that what we're doing here at NASA, we are going to be picking up and showing you live pictures from Cleveland. There's also a NASA website, www.nasa.gov, where there will be streaming the view from Hawaii.
Mm-hmm.
So if you make kind of a comparison about what you see here at the NASA Glenn website and what you see at the Hawaii website, on your web, on your computer, you can see that difference.
That's right.
Very, very small.
NASA Edge is doing a gavel-to-gavel webcast, so to speak. You can get through the main NASA site. You can also get to it by venustransit.nasa.gov. And there are a number of feeds, live stream feeds off of that site. Glenn is one. You mentioned some of the others. There's a real-time data link coming from Mauna Kea, 4 channels of data. There's information coming from Scandinavia. There's information coming from Alaska. They're even taking looks at this event from the International Space Station. So anybody that can see the sun during this time period, if the weather's good, you will see Venus in silhouette against the sun and be able to participate in this activity, whether you're part of the calculation or just enjoying and celebrating with us the joy of scientific inquiry as it's expressed through solar system exploration the easy way in an easy chair and watching the sun.
And there's a real use of mathematics here
Very much
to
so.
figure out when they were trying to estimate the astronomical unit, when they were looking to try to determine mathematically the distance from the sun to the Earth. They were using the information from the transit of Venus.
That's right.
But they used a lot of mathematics.
They did. A lot of trigonometry.
Trigonometry. Okay,
Yeah, the science of triangles. The stuff you study in school. It does have practical uses, and this is one of them. And it's nothing more complicated than playing the jumping thumb trick. You hold your thumb at arm's length, close one eye, move your thumb over an object, then alternate eyes, and your thumb appears to move. Of course, you're holding your hand still, but that difference is because of the separation of your eyes. That's how we get depth perception. And change, instead of positions of 2 eyes, put 2 observers on different parts of the Earth, and you get the same idea. That offset is very small because Venus is very far away, but that's the principle. If you know how long your arm is and can measure how far your thumb appears to jump, you can tell how far away the object is you're holding up against.
Incredible.
And this is nothing more than a larger scale version of that activity.
And who figured this out?
Well, the original concept is said to come from an astronomer named Gregory way back. but it was recognized and publicized. His method didn't work as well. He was trying to do it for Mercury transit, harder to see. But the comet guy, Edmund Halley, before he passed, figured out that a transit of Venus would be even better and worked out the mathematics based on Gregory and the earlier work. And when you're the comet guy, you get your word out pretty good. And he knew he wouldn't make it to see it himself, but that was the impetus for the 1761 and 1769 expeditions. That was big science back in those days. That was the space race of the 1760s. And
different nations
were competing to make this
cool.
calculation. There was a French group. Captain Cook was part of the English group. There were even some Americans involved. So this was a very exciting time for science. Now, not everybody had a good expedition. There was a Frenchman by the name of Legantiel who was sent by the French Academy of Science to see the transit of 1761. The place he was sent to was a French colony, at least when he left home. Okay. It changed hands before he got there, and they had to shuttle around. He ended up seeing the transit while he was still at sea and couldn't make meaningful measurements from a moving platform. Okay. But travel being what it was in the 1760s, he decided to stay in the Indian Ocean area for the 1769 opportunity.
Okay, you got the 8-year jump.
It was an 8-year jump, but there was valuable surveying and scientific work to be done, so he carefully collected data on matters unrelated to Venus transit and waited and bided his time, got all set up, got a good observing site established, got his observatory built, surveyed into position. The monsoons were in, the weather was going to be good. You know where this is going. They had one rainy afternoon the whole time. Yes. Yeah, so imagine being there for 8 years waiting and to get clouded out.
And they rained out.
So on the way home, of course, there was a hurricane and a shipwreck and all the trials, and he got home. And his heirs were fighting over his possessions, and there had been problems with money. But he got married and had a kid and lived happily ever after for 21 years. So let's hope that that went okay. They even wrote an opera about the travel travails of one Legantiel.
Now, the fact that these things happen, 2 of them together, 8 years apart, and then it's roughly 105 to 120 years, take an average 115 years in between them, technology changes a lot in 110, 115 years. Right. So in the 1760s, when they were trying to observe this, of course, cameras weren't hadn't been invented, so you couldn't take pictures.
Not good pictures.
You didn't have television, you didn't have the World Wide Web, you didn't have calculators.
None of that stuff.
You didn't have a lot of things that we have today. How has all that changed? How has the new technology allowed us to do it different every 100 years?
Well, there's always been a reciprocal or synergistic relationship between science, scientific inquiry, and the technologies that enable it. And as technology gets better, we can ask more sophisticated questions. And the more we learn that we don't know, and the more we learn how to do the technology to enable us to answer these questions. You're right. The very first transits back in the 1760s that were scientifically observed were done with primitive equipment by today's standards. They didn't even have a good way to determine longitude at sea. The Harrison chronometer hadn't been in general use. So they had a lot of hardships, but these were dedicated observers that literally went to the ends of the earth for the data. With subsequent transits, our knowledge had increased, and we knew how to do things better, so our questions were more sophisticated. We don't have to worry about determining today the Earth-Venus distance. We know that from other means. But there's still good science being done, and one of the coolest ones that I've run across is to use the Hubble Space Telescope in a way that the designers never envisioned. It has very sensitive equipment. It's built to look at faint objects, not the sun. It's never pointed at the sun.
If you pointed it at the sun,
you'd wreck it.
You'd lose the spacecraft.
So the way to beat that and the way to make it useful for Venus studies is to take advantage of this event, and that's what they're doing as we speak. They're gearing up. The sunlight during the transit will be passing through, at least some of it, through the Venus atmosphere, and will hit the moon, not the Earth. Some will hit the Earth, of course. but only a little will be reflected by the moon. The moon's pretty dark. And the Hubble telescope can look at sunlight reflected off the moon without damage. So the idea is to use the sun or the moon rather, as a reflecting filter and look at how the sunlight is changed by its passage through the Venus atmosphere, which will help us understand the Venusian atmospheric chemistry and composition. Now, we already know something about that. That's useful, but we're also looking at other planets orbiting other stars now, and we want to look at how the star's light changes when the planet passes in front of it to see if we can tell something about the chemistry of those planets' atmosphere, if they have it. And this is a good test case to do it in our own solar system close to home. You bet. Make sure that the technique will work and that kind of thing. So there's a way people thought that they never thought of before, figured out how to use this.
Incredible, incredible. So, when we talked about this other spacecraft, the Kepler spacecraft is a craft that NASA launched. It's about about 1 million miles from Earth. I believe it's at one of the libration points. And it's looking off in one small section of the sky. And what it does is it's got a lot of photometers on there, and it's measuring the change in light of thousands of stars.
One little section of the sky.
And one little section of the sky. And whenever you detect that little change in the intensity of light, if it's repeatable, that's indicative of some planet passing in front of the
It's either a spot on the star or something that's orbiting.
That's right.
And there are ways of telling that apart.
And now we're trying to make that method even more sophisticated to try to get at what's on that planet.
And that's just, it boggles the mind that we're able to even conceive of such things. And, we've discovered there's thousands of candidates that are being investigated further, and I think the latest count was just under 700 exoplanets discovered by this method. And that number's a few weeks old now, so they're finding them all the time. It might be higher still. It might be over 700.
But that's, again, part of the legacy of this observation of one object passing in front of a star.
Exactly.
And it just doesn't happen that often. And you've got to be. And today's the day it is.
Today is the day, so don't miss it. If you can get outside and see in good weather safely, by all means do so. For most of you, certainly in the continental U.S., the sun will set with Venus still in transit. So at some point during the event, be sure and go to one of the websites that's showing it live, like venustransit.nasa.gov, and check it out for yourself. You have something to tell the kids. This is a real cool event, and you won't see another like it, I guarantee.
Now, we're talking about what transit of Venus tells us about Venus, and maybe what transit of Venus tells us about planets orbiting others. What does it tell us about Earth? Anything?
Well, only indirectly. I mean, anytime the ultimate reason for studying other planets and doing a lot of things that we normally considered as astronomical is to apply what we've learned back here on Earth. And we're learning a lot about the sun. The transit of Venus touches on, of course, the sun and Venus directly. If we learn more about the sun, that's the giver of life for us. That's kind of important.
Source of all power.
Source of certainly we couldn't exist without it. And Venus, for a number of reasons, is an important place for us to understand as well. It's about the same size as the Earth. It's about the same mass as the Earth. That means it's got the same bulk density as the Earth, which indicates it probably is made more or less out of the same stuff as the Earth. And that's we would expect Venus to be a little hotter.
And yet it's different.
But it's way different.
That's right.
It's not a little different. It's a lot
We're going
different.
to be talking to some people today who work out at the NASA Glenn Research Center who are involved in this study of how Venus is different than the Earth, why Venus is different than the Earth. Like you said, there's two things that theoretically should be pretty similar, and they're not.
And Venus has had a greenhouse effect. And when did that happen? Why is it different than Earth? Did it happen early in Venus history, or did something happen to Venus later on? What's going on? Why are these things so different? That's a really fundamental question for us to really understand about our own planet. So this is a way to showcase a lot of the good research that's being done on the giver of life and our non-identical twin.
Evil sister.
And evil sister, and it lets us know to understand how many stars, what the percentage is that have planets, is a really important datum for a lot of things too, including trying to assess the possibilities of life elsewhere in the solar system. The more planets there are, the more chances there are.
Yeah.
So we're now finding out there's a lot more planets, at least stars. More stars have planets than we had previously thought. So that's pretty exciting stuff.
Now, the transit's going to start in about 10 or 15 minutes. And when it starts, there's something weird that happens. It's the easiest way to put that. And that is that as it comes passing in front of the sun, you'll see you'll see the bright disk of the sun, you'll see the sky behind it, and then the little black piece that is Venus will start to move in, and just as it moves off the end, something weird happens.
Something weird happens. It looks like a little piece of the dark follows it onto the sun. It's called the black drop effect. And it was part of the reason. It actually turns out to be a fairly complicated phenomenon. But
I was going to ask you why.
No, don't. It's a little bit complicated, and to be honest with you,
Okay.
I don't fully understand it. But my good colleagues at Heliospherics Division do, and there's information on the NASA website about that as well. But it certainly is an interesting effect. Now, with scientific inquiry, you never know what's going to happen, and sometimes the thing you expect to learn, something happens you can't do it,
That's right.
and then something else you find that you weren't expecting. And when we discovered the black drop,
unexpected consequence.
Venus was also seen from the black drop and from other lines of evidence to have a dense atmosphere, and that was an important line of reasoning as well. So,
Okay.
so this was an exciting time scientifically for a lot of reasons. And hey, come on, the name black drop, that's pretty cool.
That is pretty cool.
I got messed up by the black drop.
You know, I had in preparation for coming to talk today, I did a little research on the websites trying to find out about the black dot. And I found about 4 explanations, all of them different.
All of them different.
And it
now you know
made
why I'm
me
hedging.
well, and it made me think that maybe this is going to be another source of inquiry. That I want kids to know, in particular, kids are watching this broadcast. All things are not known.
That's the truth.
Okay, you don't go to school to find out everything that's known and as if everything is known. We're starting to find out things about dark matter and dark energy and black holes and things like that when you and I went to school, I think we're about same age.
Let's not go there either.
These were not even known.
That's right.
Not even
That's right.
discussed.
And,
So there's a lot of things we're learning out there. This is a new age.
Well, absolutely.
and
I
we
mean-
want kids to consider doing careers in this. I know you work in education at the Air and Space Museum. I work a little bit of education
You do indeed.
at NASA Glenn for exactly that reason.
Exactly so. And, you know, science isn't a dead, static body of factual information about the natural environment. It's a process. It's a process through which we learn these things. And it's self-correcting, so that means there's always opportunity to advance the pool of knowledge further. That's what we do
Yep.
collectively, many different roles as part of a grand endeavor. And that's exactly what we're celebrating here today, is the representation of the efforts that we've all made collectively that have resulted in a state of knowledge. And who knows, we may have the next Mars walker right here in this crowd.
Or the new Galileo.
Or
the
the
new
new
Galileo
Galileo
might be out there right now.
There's-
Or the new Edmund Halley. Or the new...
A lot of exploration. I can't even say it now. Exploration left, and a lot of things left to learn. So we're looking for help. So do good in school and keep on learning, regardless of your age and background. This is an opportunity for learners of all ages to participate.
Okay. Steve, we're going to bring in another speaker here.
All right.
I want to thank you for coming
Thanks,
by
Tom.
today.
My pleasure.
If you want to come back later, because we're going to be on here for a couple hours.
I'm not going anywhere.
All right, great.
Thanks,
Tracy,
everyone.
we may want to grab Steve again. We've got a lot of other things to talk about.
All
But
right.
we'd like to bring up one of the engineers from the NASA Glenn Research Center. If we can we bring him on in, Tracy? Somebody's giving me the 5, 4, 3, 2, 1. I think we can do a transition here easy. Okay, right now what we're looking at is this is kind of a test of our camera system. This is a live shot of the sun, and the transit hasn't started yet. So if you're straining your eyes trying to see the little black dot, it's not there yet. This is going to start in about 10-15 minutes, but I wanted to bring in another speaker right now. Let me jump around here a little bit. I'm looking for you, Gary.
I'm around here somewhere, I guess.
I know you're around here somewhere. Gary gets the, got to hold the microphone up.
Closer up?
Yep.
Alrighty. Like so? Is this okay now? Okay.
All right, you can tell this is live television.
We haven't dropped anything yet, but
Not
anyway.
yet, not yet. This is Gary Hunter, and you're a senior engineer out at the NASA Glenn Research Center.
That's correct, I am.
Okay.
I've been there for about 21 years now, working on a range of projects over time.
Okay, and your particular specialty is instrumentation, is
That's
that correct?
We're in the Sensors and Electronics branch at NASA
Okay.
Glenn. We work on a range of technologies and a range of applications. The area that I'm in involves, for example, chemical sensors on one side, where we do breath monitoring on one hand, and leak detection and fire detection and emissions monitoring. But we also do work associated with high temperature electronics and high temperature sensors.
And that's the interesting piece for today's exercise, is the high temperatures. The instrumentation that you work on, a lot of that's used on jet engines, things in day-to-day, things people fly on, and yet that technology would have a real application when we get to land things on Venus, correct?
That's what we would hope. The idea is this: you have electronics and you have smart systems that are operable at room temperatures. Your cell phone, your TV, your whatever type of computer you might have. Those technologies work well at room temperatures, but when you try to bring standard electronics up to higher temperatures, well, they're going to have a hard time. They don't operate well at high temperatures. And so the idea that you might be able to put something on Venus at these high temperatures is something that we would like to do. And if you're going to do that, as you just heard, the idea that you would want to be able to have sensor systems that can operate at 500 degrees C, at pressures 90 times and more than what we're used to on the surface of Earth, all of these things make the idea of trying to have anything stay on the Venus surface and live for a period of time problematic, a challenge.
Okay, now in the past, probably back before I came to work at NASA, back in the 1970s, the Russians landed some spacecraft on Venus.
They did.
Correct? That's right. And how long did they last?
Limited time, we'll call it about 2 hours or so over the period of time.
And in that 2 hours, they burned up, melted
Well,
up?
there were a number of things that might have happened. Let me just say that to live on the surface of Venus for an extended period of time, you need a range of technologies.
Okay.
You need to be able to, if you're going to make measurements, you need the electronics to work there.
Okay.
You need the instrumentation to be able to do the measurements. You need the power to be able to keep the system operational. You need a range of technologies that we take for granted at room temperature, but at 500 degrees C, 90 times the atmosphere or more of Earth pressure, it's not straightforward, it's not simple. But it is relevant to the degree of the types of stuff you have to do when you're talking about a jet engine.
Okay, so it's kind of funny. Things that we learn trying to send a ship to Venus helps us build a better jet engine.
Well, let me say this way. Our work over time has been to build a smarter engine.
Or vice versa.
Vice versa, yes. Because we're doing more on the engine side than we are on the Venus side at this point.
That's right.
But the idea that we have some of these core technologies, because we're trying to make smarter engines. We're trying to make engines that, for example, can have measurements that weren't available before, that could even, for example, have some form of wireless technology associated with the hotter sections of the engine. All of those things are things that have relevance if you wanted to go to Venus.
Okay.
Because one of the things we're working on is a Venus seismometer.
Okay. Now, for the kids out there that don't know, a seismometer measures
Vibrations on the surface. If there's an earthquake, Seismometers would tell you about the magnitude of the earthquake and directions and properties associated with the earthquake.
Okay, so when we say something like on the Richter scale, it was a 5.4 earthquake, that 5.4 is a measure of the seismometry, of the motion.
That's right.
Okay.
That's right.
So-
And one of the things about a seismometer, if you're going to measure that motion, you got to be on the surface measuring that motion.
Okay,
You
all right.
can't do it 100 feet away. You can't do it miles away. You got to be sitting in there. And for Venus, that means you got to be hot.
Okay. Because the surface of Venus, I guess we haven't really spelled that out particularly, but the surface of Venus is about 900 degrees Fahrenheit, roughly, from the measurements we've taken from above and from where the Russians landed, and about 90 atmospheres. So it will crush, it will melt normal operating machinery, unless you cool them or unless you do something really special.
And we're trying to do something special.
Right. Right.
We're trying to make electronics that'll be able to operate at those temperatures.
Okay.
And the idea is and I'm sorry, I think in degree C,
Right.
500 degrees C is what we talk about. The idea that you have high temperature electronics, the idea that you have systems that can process data, communicate data, make measurements. Those things have applications in engine applications, industrial processing, and on the surface of Venus.
Okay.
And so part of what we're doing then is that we have some work on trying to make aircraft engines safer. That includes high temperature electronics and sensors and communication on one hand, but we're also trying to make the seismometer with very simple circuits. The circuits we have now have operated at 500 degrees C for thousands of hours.
Oh, awesome.
Already at this point.
Okay, so
Except there's-
so you can test them at the lab in a
Yes.
special facility.
There's two things. You can put them in an oven at 500 degrees C and let them go for a long period of time.
Okay.
And we did for thousands of hours.
Okay.
These are simple circuits, though. These are
Okay.
NAND gate. Well, I don't want to go too far, but these are very simple, basic components.
Okay.
We're trying to get more complex, but right now we're simple. And I could sort of list them, but they're just the very basic building blocks of how you make a more complex circuit. We've already shown a few years ago that we can do that. Now we're trying to use some of those simple circuits, put it together with a seismometer system. Again, a very simple seismometer, or something that what they would call a geophone, measures basic vibrational properties.
Okay.
Stick those two together and begin to show the ability to take some vibrations, measure them, and process some data and do some limited communication with them.
Okay.
The first step, the foundation towards wanting, as I think we said earlier, we'd like to go to Venus.
Right.
The idea that you can go to Venus and actually be there for extended periods of time, to be able to understand what's going on that surface, that will help us understand what's happened to Venus. What are
Right.
some of the
As
properties?
Steve was mentioning
Yes.
earlier about Venus looks like the Earth. It's about the same size, and yet things are very different there. Why are they different?
Exactly
What
right.
happened there? And this question of is there plate tectonics?
Right.
Is there a molten core or is it a solid core? Or exactly what's going on there?
Right.
These kinds of things can be answered with this kind of instrumentation.
And while we're at it, we want to do more than that. We want to do the vibrations and understand the plate tectonics.
Okay.
We also want to have sensors there, and we're developing them for other applications as it is, that measure temperature and strain and heat flux, that measure chemical species, that measure pressure. Not only have a seismometer, but a weather station on Venus.
Okay, very cool.
All again, 500 degrees C. I've heard multiple analogies, but it's like turning on your oven to the cleaning cycle and then putting it at the bottom of the ocean. Not a good environment
Not
to
a
put your
good
cell phone,
choice.
for example.
But these are the kind of things that you as an engineer at NASA, Glenn, you work with these kinds of things every day.
We're working on high temperature with a lot of people. We have collaborators both within our group and elsewhere. We work with scientists on the outside for the seismometer and in industry on the outside and the seismometer. We work with other companies to stick literally sensors at the back end of engines and measure their emissions as they come out and measure a range of different things.
All right.
So those, yes, the idea that we handle tough problems, we try to push the boundaries of technology, make things, the way I phrase it, small and smart and operable at high temperatures. That's some of the stuff we were up to and have been up to for a period of time.
Now, again, for the kids that are tuning in on this, and for the people that really don't know what engineers do a lot, this thing of working in the lab and doing the experiments and figuring out the technology is only a small part of what we do. We also have to go tell other people what we do. You have to have some communication skills, and you have to go out and tell people what you're doing. I think people should know that you are on your way in about 10 or 15 minutes. While Venus is transiting, you'll be transiting to the West Coast. Is that correct?
Exactly right.
He had a flight scheduled earlier today, and you get the Above and Beyond Award for the presentation today for coming out here. You chose to come out and talk to the people and see the people here. But you're going to give a paper out in California, that's right?
On the need for high temperature wireless systems in aerospace applications, engine applications.
Excellent.
Which is quite relevant to all the things I just talked about, as it turns out.
That's right.
So, and I'm honored to be here. Thank you very much for having me.
Okay, well, we have a lot of fun with this. I think that's something that you viewers are going to see all along the line here, is that the scientists and engineers, by and large, we have a lot of fun. This is fun stuff we do. It's difficult. We make a lot of money doing it, but we sure have a lot of fun doing it. So what I'm going to do is I'm going to bring up, let's see, the transit has started. Let's switch off and let's go take a look at the view of the sun. I want to thank you, Gary, for coming out today. Good luck. Have a safe trip out to the West Coast.
Thank you, sir.
I'm sure your paper's going to go great.
We'll give it a shot.
Okay,
thank you,
great.
Sir.
All right, let's see if we can switch here. Let's see if we can switch to the camera and see what's going on up on the sun. Can we see it yet?
Oh.
I think I'm watching my monitor. There we are. Do we see the little dot coming in yet? It's coming in. Oh, careful there. There. I think there it is up near the top. There's a little black dot right near the top. Can you see that? Come on up here and sit down.
Yeah, I can
Come on.
see it.
Can you see it?
Yeah.
Yeah, see that little black dot?
See it, Alyssa?
That's Venus. All right, we've been talking with some past engineers, some of us older guys, and now we're going to actually get to talk to somebody who maybe is going to become an engineer. Thinking about that? Let's see who we've got here. We'll use first names only. You are?
Chase.
Chase. All right, and you are?
Alyssa.
Alyssa. Great. Why'd you come out here today?
Well, because we wanted to see the Venus transit.
You wanted to see the Venus. Did you take a look yet?
Yes.
What'd you see?
Well, we don't see anything yet because we have viewers.
Is it just getting started?
Uh-huh.
Kind of cool. Why don't you turn around here so they can see you on the camera a little bit? I'll hold the microphone for you. So do you guys thinking of becoming scientists?
Yes.
Yes. Great. What are you studying in school?
I like science. It's one of my favorite subjects. And I am just at the chapter of space.
Okay. What grade are you in?
Third.
Say again, please.
Third.
Oh, cool. Are you excited for the summer coming up, summer vacation?
Yes.
All right. Is this your older brother?
Yes.
Okay, older brother. When summer vacation comes, do you forget everything you learned?
No.
No, this guy knows his stuff. You're going to be successful. Did you want to be a scientist, or what would you like to do when you get a little older?
Pilot.
A pilot? What kind? Airlines? Fighter pilot? Navy? Air Force? NASA?
Private.
Private. Oh, you want to fly airliners?
Not particularly, like the small planes, like a Champ.
Oh,
Or-
cool. Have you taken any flight lessons?
No, not yet.
Not yet? You know, when you want to become a pilot, there's some things you've got to study that are very important. Can you guess what that is? How would I
Navigation?
get navigation, exactly. And navigation uses lots of, I bet your sister knows, navigation uses lots of
Science.
science and 5 divided by 2. A lot of science and
Stars?
math.
Math.
Math. Yeah, a lot of science and math. Math's fun. You like math?
Yes.
You know, you start to like math when you're about your age. If you guys really like math, when you get old and gray and look like me, you could become a scientist or an engineer. You might be a scientist or an engineer for a long time. I'll let you in on a little secret. This is kind of a cool secret. Do you know who the first guy on the moon was?
Neil Armstrong?
Neil Armstrong, good man, Neil Armstrong. Neil Armstrong was the first guy on the moon. And when he went to the moon, he was 38 years old. Now NASA wants to go off and go back to the moon and go on to Mars. But we aren't going to be able to do it for 30 years. It's going to take a long time to build the spaceships. How old will you be 30 years from now? 30 plus your current age.
38.
38! 38! You'll be the same age as Neil Armstrong. Now, what that means is the first person that gets to go to the moon or gets to go to Mars is somebody your age or somebody your age. I'm too old. You look around here today at all these people around here, most of them are too old. They'll never make it. But you guys can make it. And to do it, you got to keep working on your science and math. You like science and math? Well, of course you do. That's why you're out here today. What do you think about all this stuff? What do you think about? Do you like to think about Venus and about the sun and about the moon and stuff like that?
Yes.
Did you ever write stories about this?
No.
Not yet.
Not yet. My pilot here, you're gonna fly her? Maybe she'll get to be the first one down the ladder. You can fly her there. How's that work out?
I think she's too scared.
Too scared? Oh, come on. We're not scared. Oh, we got another person here. Thank you, guys. Team USA. Are you ready for the Olympics?
Yeah.
Yeah. Have a seat. You are first name?
Molly.
Molly, how you doing?
Good.
What'd you come out for?
See the transit?
Did you take a look yet?
No, I couldn't see it from the viewer.
You couldn't see it from the viewer? Let's see. Did I have one of my viewers around here? I might have a viewer. Did I give you a viewer?
Yeah.
But you just couldn't quite see it yet. Oh, here we go. We got a viewer. Want to take a peek? Now be real careful.
No, not visible yet.
Can't see it? Do you mind if I take a peek? I've been stuck here and I haven't had a chance to take a peek. Oh my gosh. Yeah, you'd have to have pretty good eyeballs to see that.
Yeah.
I think a young person like you've got pretty good eyeballs, right?
Yeah.
So, are you thinking of becoming a scientist?
More in the medical field, so
Well,
you
that's
might.
science. Come on.
Yeah.
What do you think medical guys do? Besides make a lot of money.
Yeah.
No, you like science and math?
Yeah.
Are you pretty good at it?
Yeah.
Where do you go to school?
Ford Middle School.
Oh, in Middleburg Heights?
Yeah.
Oh, that's where. Yeah, I'm from Berea. That's a local suburb of Cleveland. For people that don't know, it's really good school, excellent school system. My kids went through there.
Uh-huh.
My daughter is actually a psychologist, graduated from Duke, and so they give you a really good education down there. You like the math?
Yeah.
You pretty good at it? Yeah. Okay. Very good. Very good. And you want to do medical things?
Yeah.
Do you volunteer over at the hospital, or are you a little too young for that yet?
I haven't, but
Okay, you're thinking about that, maybe?
Yeah.
It's good to get a little experience before you get out there. Now, I'm going to be kind of selfish here. NASA has a lot of doctor astronauts. Okay, if you want to become a doctor or some kind of medical profession, and you're gutsy enough to get on a rocket ship, I don't think NASA would kick you off. I think they'd be glad to have you aboard. Because it sounds like you're interested in lots of things. You're interested in more things than just math and science.
yeah.
Do you play music?
Yes, I play the trumpet.
Excellent. I'll let you in on a little funny one, too, with that. When you look at the general population, there are a certain number of people that play musical instruments. If you look at the engineering and science population, more of those guys learn to play musical instruments than the regular population. I don't know whether it's, there's some studies that prove this, and they don't know whether it's just the discipline that you need to do that you start to think that way, or that science, a lot of times, even medicine, there's a bit of art to it. Besides science. We don't want to do, and you learn to work on teams. You got a Team USA. Do you play sports?
I did track and field for Ford.
Excellent. What did you do for track?
I did shot put and discus.
Excellent. Cool. So you do the heavy lifters.
Yeah.
You're going to be watching the Olympics this year?
Yes.
Yeah. It's too bad. Those happen a little more often than Transit of Venus, so we get to see those every 4 years.
Instead of every 100 and something.
I think can we have her here as co-host? She seems to know her stuff. Where'd you hear about the 100 and some years?
They announced it.
Yeah, but you remembered it. Excellent. 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 Good job. So what are you going to do this summer?
Well, I'm going to band camp, then sports camp,
Oh,
and I'm
cool.
going to play soccer.
This is a good example of a successful person. For anybody that's watching out here, no, you'll be a very successful person. I know that already, because you're not going to sit around this summer and just watch TV or do something. No, you're going to go out and do things. You're going to participate in things. When you like what you like what you're doing, don't
Yes.
you? I can tell that. When you like what you're doing, you put in the extra time, you become really good at it. Well, I bet you're going to have fun this summer. When you get back to school, I know you're going to have more fun.
Yeah.
You're going to forget what you learned this year in school during the summer?
Maybe some of it.
No, bad answer.
I'll remember the important stuff.
Huh?
I'll remember the important stuff.
You'll remember the important stuff. I'll let you in on a little clue. Everything is important. Okay? You've already doing that. You've got lots of interests. We've talked a little bit about music. We've talked about things in the sky. You've talked about sports. You've talked about math and science. There's lots and lots of stuff out there. History and the election this year. I mean, there's all kinds of stuff that's going on. And take a shot at all of it. Don't let any of it pass you by. And I think you're going to be very, very successful. If you decide to come work for NASA, okay, you let me know. Okay. We'll get you in the gate. We want you to come on out. That's right. We're looking for top people. And I'll let you in on another clue. This is kind of scary. When you look at NASA people, they look like this. Okay? There are a lot of old people working for NASA. And there's a lot of us going to be retiring. And when we retire, young people like this are going to come in there and take our jobs.
Yeah.
And we want you to head off to college. We want you to work hard in high school. High school's coming up, and what you're doing in middle school is going to help you in high school.
Yes.
And then we'll see you come work for NASA. Okay?
Okay.
All right. Shall we go see what's going on with the transit of Venus? Say again? I can't. Oh, we've got another person coming in here. I think we're going to switch off microphones. Thank you very much, Molly. We'll see you on Mars. Oh, look at this guy.
All right, you ready, buddy?
Excellent. Where did you get that shirt?
From my grandma.
From your grandma. Are you grandma? You mom?
No, Mom.
Mom? Hello,
Grandma's
Mom. I
over
know
there,
your mom.
yeah.
Where's grandma? Grandma, excellent shirt.
No, his.
His. Yours is excellent too. That's. What are you doing out here today? What'd you come to see?
The show.
The show. Okay. Did you get one of the magic goggles?
There you go.
You got to get one of magic plates. Did you take a look at it? Here we go. We got the secret guy with the table. You know, have you seen one of these before? You know how this works? We'll let
just
Mom
talk
hold
into
on
it.
to it. Yeah, you just talk into it.
What planet do we see?
Venus.
Venus. Oh my gosh. Do you know about the planets? Look like you got the planets on your shirt. What's this one?
Earth,
Earth. What's this one?
Venus,
Venus. What's the red one?
Jupiter,
No, the red, all red.
The big one. Oh, the big one with the red spot. What's that one?
Jupiter,
Jupiter. This guy. What's the one with the ring?
Saturn,
Oh my gosh. And the little red one over here?
that's the orange one.
Or is that the moon? What is that one?
Moon.
Moon. You got one around here too. Oh my gosh.
That's
You've
it.
got them all. You sound like you want to become an astronomer or a scientist.
Do you have your own telescope at home?
He's got his own telescope at
Two
home.
of them.
Two telescopes. Would you put one in each eye?
No.
Is it a great big telescope?
Only one is great big.
Well, one's great big and one's little. Do you use the little one to kind of line up the big one?
No.
No. Have you gone out and looked at the moon?
Yeah.
What'd you see?
What does the moon look like through the telescope?
I don't know.
Don't remember?
Pretty big, huh?
Yeah. Wondered whether you saw any, did you see any craters
Only moons.
on the moon?
What made
Yeah.
the craters on the moon?
Moons around them.
Oh, they're all kind of round?
Yeah, around the planets.
Do you remember how the craters got on the moon?
No.
Okay.
Well, we're all wondering that a little bit. But you know what? You want to become a scientist, you can figure it out.
Would that be a good
Scientists, to be
Yeah.
honest, scientists a lot of times, we don't know the answers. I'm a scientist. And most of the time, we don't know the answers. We got to figure it out. Are you pretty good at figuring things out? You like to do puzzles?
idea? Oh, that's
Oh,
his
if
favorite.
you can do puzzles, you will be a good scientist. How do you feel when you get the puzzle done?
What do you say when you finish a puzzle?
Ta-da.
Yes, you betcha. Well, that's what us scientists do. When we work all day, we work for months and months and months trying to figure something out. And when we get it done, yeah, we got it done, just like you. Are you going to come work for NASA someday? Do you know what NASA is? NASA. Did you ever hear of those guys? What do we do?
Scientists
Scientists, yeah.
Yep. Where do they go?
and do odd stuff.
They what?
They do odd stuff.
Rocket stuff.
Rocket stuff. We do rocket stuff. I'm going to let you, if your folks will let you stay up late tonight, there's something really cool going to happen.
Do you remember what's going to go over really late? Remember we heard it on the radio?
Venus.
No, Venus
Nope.
is going by. What's
Venus
gonna
is
go
going
overhead?
by, and late tonight, something special's going to happen.
Where do the
I don't know.
astronauts go?
In fact, they're just talking about it back there in the background.
They're going to go overhead where the astronauts go?
Yeah.
Where do they fly up to?
I don't know.
The
Don't know?
Space.
Space what?
Space station.
Space station. He's got it. Yeah. The space station. Did you ever go out and see the space station fly over?
We did.
What does it look like?
I don't know.
Don't know. It's kind of fun. It's usually a big bright light in the sky.
Yeah.
And even an old guy like me, I go out in the front yard and I stand there and I watch, and kids come around and we tell them, oh, right at a certain time, here it comes. And then a big old space station will come across. And then what does it do? Did you ever get to see it? It does something really cool.
What does
What?
it do?
Sometimes it just disappears.
Yep. It blinks
It
off.
just blinks off. And what's really weird to think is there's people up there. Right now there are 6 people up on the space station. And one of them is a very cool guy. There's 2 Americans up there, and one of the Americans used to be a school teacher. His name's Joe Acaba. And Joe will be looking out the door. He'll be waving to you when he goes over. So you be sure and wave back to him, okay?
And what does the astronaut's hair do up on the space station?
Floats.
Floats around. Oh, has he seen the movies?
Yep, yep.
Oh, yeah.
Everything floats up
Yeah, I
there.
do distance learning talks with kids a lot, and we show the movies, particularly ones from Sunny Williams. And Sunny is going to go up and become commander of the space station in July. And she has she's from Cleveland originally, from Elyria, and she likes kids to learn about it. She's interested in having this guy come become an astronaut when he gets a little older.
Yeah,
Would you do that? Would you think about that? Become an astronaut?
Yeah.
Would you have enough guts to get in a rocket ship and go up?
Yeah.
Oh, I like it.
He's a brave
Well, good
guy.
deal. You have fun today looking at the transit of Venus. It's kind of sad, you'll never get to see this again.
Hey, you never
Even
know.
well, we can do the math.
Maybe the little guys.
You'll have to. We'll need some medical breakthroughs. We'll have to get you up to get life expectancy up to 120 years or something.
Right.
You might make it.
105 years.
105 years.
105 years. Can you add? Are you learning your math yet?
I am already.
You already know your math? How many's 5 plus 5? That's a tough
You
one.
have 5.
Okay, we got
five.
5, and we add 5 more.
6, 7.
I see the wheels. You can see the wheels. Excellent! He got it. Good. He's got it. Excellent. You are a math whiz and a science whiz, and I love your shirt.
Yeah.
If it was a little bit smaller, I might take it from you.
Would your shirt fit on him?
Yeah, you think I'd strip? Nah, it wouldn't fit on me. Maybe we can get Grandma to make me one of them shirts. Well, we want you to have fun out here, okay?
All right.
All righty, shall we go see what's going on the transit of Venus?
Can you say
Thank
thank
you
you?
very much for coming by.
Can you say bye, Ben?
Bye.
Bye.
Thank you.
I want people to watch for this guy. This is liable to be the first guy on Mars right here.
That's right.
All right, when he gets there, we want you to wave to us and say, hi, Grandma, okay?
Sound good?
Deal? It's got to be a deal.
Deal.
Deal. Okay, it's a deal. All right, let's go take a look and see. Oh, hey, look here. Can you see that? Look right over here. You can see the little dot. See the little dot?
There it is.
Right there.
See it, Ben?
See that?
Yeah.
Can you see it, Ben? We can see it on the camera here a little easier than you can
Yep.
see it up there. See
That's
the little
Venus.
dot? Oh, yeah. Isn't that weird? Yes. Now, over here in the NASA tent,
gotta come up now.
they're putting a projection of that. Got you. All right. Okay, thanks, Ben. You were great. Oh, it was our pleasure. That guy's incredible.
Oh, you didn't move the chair? Okay.
Hop on in, Ann.
All right.
Okay. Okay, I don't know what all that signal was. We got things blowing away. Very good. All right. What'd you think of that little guy?
Oh,
was that something?
he is something. I love that shirt. Very cute.
Okay, let's see. Oh, they're still showing Transit of Venus is being brought. Can you see it? Can you see it right at the top?
I can see it.
I think it's actually a little bit easier to see here on the TV monitors than if you were seeing it live. I was looking
Yes.
through some of the some of the view scopes, and it's pretty small. It's kind of hard to make. Whoa! And there went a bird by there.
Yeah. That must be
All
one of the
right.
telescope views there.
When are they coming back to us? Are you coming back to us? Hopefully they're coming back to us. When they
Yeah.
come back to us, hey, there we go. Hi,
here
this
we
is
go.
Tom Benson again, and I'm here with Ann Over.
Yes.
And Ann, you work out at the NASA Glenn Research Center as well,
I do.
and you work in.
I work in the Space Science Project Office out there. I'm called the chief.
You're the chief.
I'm the chief.
The chief of the Space Science
I have
Project.
one of the coolest jobs in the world.
Really?
Yes.
They pay you to do
They
that,
pay me to do it.
and you get to work on missions too.
I get to work on mission planning places like Venus,
Excellent.
Mars, all over the solar system.
Okay. And it's kind of funny. A lot of people in Cleveland don't even know that there's a NASA Glenn Research Center out there. And yet
Yes.
we've got people like yourself who are working on exploring the planets.
Yes. Yeah, we have about 3,000 people working out at NASA Glenn, and we're working on a variety of activities. And my little neck of the world is working on science.
Okay.
We're working on mostly planetary science,
Okay.
including Venus. And so we're doing some pretty cool things.
And we've got spacecraft now that are orbiting a number of the planets.
Right.
Are you involved with any of those, or?
So we're involved, for Venus, for example, we don't have a spacecraft up there right now,
Okay.
but we'd love to go back to Venus and learn more about that planet.
So again, for kids that don't know, a research center is the place that sort of does the work before you get to do the missions.
Right,
Right.
right.
We've got to sort of lay out the path or lay the trails or figure out what has to be done to get there.
Absolutely.
And to do that.
Yes. So when you want to go to a place like Venus, and I think you had some prior speakers that talked about the great science we could do there, the tricky part is how do you get there, how do you power it, and how do you survive?
Okay.
And that's where NASA Glenn can help.
NASA Glenn, again, for people who don't know, NASA Glenn is NASA's our special mission is?
Our special mission is to develop space technologies for science missions and human spaceflight missions.
Okay.
And we also do some really cool jet engine work.
Okay. We do propulsion and power.
We do propulsion, power, and space communications.
communications.
And a bunch of other stuff, but those are the big three.
That's right. And
Yeah.
and the power part is kind of interesting, particularly when we're talking about going someplace like Venus. If you go to
Yes.
Venus
Yes.
and you get down on the surface, you're going to need some source of power, and
Right.
that doesn't work.
No. You may know Venus is covered with clouds, very thick clouds. When you get down the surface of Venus, you can't put up the solar arrays like we do so many other places. So you have to bring maybe a battery, but that won't last long.
Okay.
You could bring a fuel cell. That won't last long. Or you can bring a nuclear power source that will last a long time.
Okay. So it sounds like nuclear is the preferred way to do it.
It's the way we do it when there's no other option.
Okay.
So to be fair. So when you go to a place like Venus, it's really hard. And
Yeah.
that's one of the few options.
Yeah, I guess we didn't discuss a whole lot, but when you're on the surface of Venus, it's like a cloudy day in Cleveland, except
Right.
it's cloudy everywhere, all the
Yes.
time.
Right.
You never get a nice clear day. Today we had the terrible clouds all banked in early this morning, and then it's
Yeah.
all broken up here, and we got nice blue sky. You never get that on Venus.
True.
So bringing solar cells or the like is the wrong way to do it.
Bring in solar cells, and actually we work with mission planners,
Okay.
and they tell us where they'd like to go, how long they'd like to stay there, what they'd like to measure, and then we help them achieve those objectives.
Okay.
And so, yeah, going to the surface of Venus is really hard. Not only you don't have the sun, but it's very hot and very high pressures, and the atmosphere is not like the air here. It's almost pure CO2
Oh.
on the surface.
So you couldn't use the free, like we do here on Earth, we use the oxygen for free.
Yes.
If we want to burn something, if you want to make
Right.
a nice campfire, it's a little cold today with
Yes.
wind off the lake. If we
Right.
wanted to start a fire, that would work really good here on Earth. On Venus,
You'd have to bring everything with you,
Oh, my
and
gosh.
it's not the best place for humans to go.
Okay.
So we're going to send our robots there first. I don't think you'll find any astronaut volunteers. Even that kid would know better to not volunteer for a mission to Venus. Not the place to go.
but it's someplace we want to learn about.
Absolutely.
So if you can't go there in person and pick stuff up,
Yeah.
then you've got to be really smart, don't you? 'Cause
Absolutely.
Yeah.
Yeah, and the neat thing about Venus, it's not so far away that we can have what we call telepresence, where, all these kids that love video games today,
yeah.
they may become the spacecraft operators of the future.
Okay, sort of like we're seeing on the military side where they're flying a lot of these drones and the like,
Yes.
and you don't put that other poor kid wanted to be the
Yeah,
pilot.
right.
Lot of flying machines now we don't put pilots in.
Absolutely.
We we fly them remote, and you're
Right.
saying that would be
That would-
probably
that-
a clever way to explore Venus.
Sure.
Might be the only way.
Sure.
a
And
while.
another idea, one of our scientists, Dr. Jeff Landis, He came up with a neat idea. NASA Glenn does airplanes and aeropropulsion.
Okay.
So one neat idea is actually have a lightweight plane that you would drop off in the top of the Venus atmosphere.
Okay.
And that would actually be above the cloud deck.
Okay.
And you could put solar arrays on the plane, and the plane would fly perpetually.
Oh, how cool.
And it would keep going around Venus, and the solar arrays would make the propeller spin. And it's so thick in that cloud deck, it would just hover
It'd
above
be
the cloud
easier
deck.
to fly than here on Earth.
Yes.
Around here on Earth, the higher you go, the harder it gets to fly.
Right.
It'll still be hard to fly up there.
Still be
I've
hard
heard
to
there's
fly.
some nasty stuff in the upper Venus atmosphere.
Yeah, the Venus is really interesting. If you start at the top, even though it's very hot below, there's ice crystals on the top. Regular ice. And then you go further down, and what people often remember, there is sulfuric acid.
Sulfuric acid.
And that is it's about as nasty as you can get on the Earth. And
I
so
remember that from high school chemistry class.
That's
I bet you
right.
did the same.
We learned about it. So there's
Yeah.
not much that can survive that. But as you go further down, it actually will rain sulfuric acid, but it never reaches the ground
Oh my gosh.
because it gets so hot that
It vapor.
it vaporizes and the chemicals just change composition.
Incredible. So it's got kind of a weather pattern going on within
Right.
the atmosphere itself. Stuff that
Yes.
rains and never gets to
It
the
never
ground.
gets to the ground. It just condenses and then it goes back up, almost like our water cycle, but with sulfuric acid.
But you've got to be careful if you want to fly up in that
If you want to
stuff.
fly, you want to fly above all that.
Okay.
Yes.
I've heard or seen things where if kids are familiar with the very early Star Wars, which go back, I hate to date myself, but go back 25 or 30 years, there was Bespin World, the land that floated in the clouds.
Oh, okay. Yes.
Lando Calrissian was the
I
boss of
remember that
Bespin
movie.
World, and they
Yes.
lived on a floating
Sure.
island in a sense.
Sure.
Would that sound like something we might want to do at Venus?
So, with a twist, perhaps
Okay.
you could float around Venus. In fact, if you go to a thing called the Decadal Survey,
Okay.
the National Research Council, some of our best scientists in the world, they plan missions to Venus. One of the missions is actually using a balloon, almost like a hot air balloon,
Okay.
but different, where you can actually float amongst the cloud tops.
Oh, cool.
And so that's another way to explore Venus.
Bringing a balloon in from the top instead of
Yeah.
coming up from the bottom.
Right. So the NASA Glenn connection again, how do you power your instruments?
Okay.
How do you get your data back to the Earth? NASA Glenn has some really good communications technology to get high-def TV from places like Venus back to the Earth.
Now, if you were going to send a signal from Venus back to the Earth, now Venus, at its closest,
Right.
like it is today,
Yes.
is like 25 million miles away.
Right.
So it takes a while for communication to pass
Right.
like that. And sometime when Venus is around on the other side of the sun, I guess it could be, 60, 120, like 150 million miles away.
It could be very far away. That's like our missions to Mars. It takes a long time. And one of the things we do is we get clever about how to send those signals.
Okay.
Because if you have a rover on a planet's surface, what you want to do is send a strong communications signal to get all the way back to the Earth. What we usually do is we have a rover on the surface, then we have a satellite orbiting that actually relays that signal all the
okay.
way back to the Earth.
Okay.
And one of the things we're developing at NASA Glenn is a new communication system that uses RF frequency and laser communication.
Oh, how cool.
And so if the laser didn't work the first time, you got the radio frequency communication, more of a standard, but we have an integrated set to make
Now,
sure the mission
is that
will
the
succeed.
communication from the lander to the orbiter, or from the orbiter to Earth?
That would
Or
be
both?
it could be both.
Okay.
In fact, it could be both.
Oh, clever.
Yeah.
And getting that good, it does no good to put a ship on Mars or put a ship on Venus and then not be able to talk to it. Or not be able to
Absolutely.
have it
That's the
send
name of the
information.
game, getting the information back to the scientists so we can model and answer some of those big questions we
And
want
I
to know.
would think I have a hard time with my computer a lot of times because of the slow rate that information gets downloaded to my computer.
Yeah.
Does that become a problem in space communications as well, or not so
well,
much?
it does become a problem the further out you get.
Okay.
And that's why NASA's investing in other forms of communication. With the RF energy, it spreads out in a V shape.
Okay.
And the further out you are, the weaker the signal.
Okay.
But we've developed a new radio frequency. It's called Ka band.
Okay.
And we're able to send signals at about 100 megabits per second. So that would be about 4 high-definition television channels at once.
That's not fair.
Well, so that's what our scientists need.
Can we get that? Can we get that technology into my television?
Well, we let the ground people work on your TV, but we work on the space applications.
That's incredible.
Yeah.
I bet you have fun doing this.
I do. It's great, and I really love working with my colleagues. And everything we do at NASA is teamwork.
Yeah.
And so you communicate with others. There's really smart people out there, much smarter than me, and I just feed off of their energy, and we produce some really nice things.
When we were talking to kids, and I hope there's a lot of kids out here watching on the web right now, but when we talk to kids, a lot of kids ask us, what should I study in high school to become a rocket scientist or to become an engineer? And I always tell them that play in the band or play sports or do things where you have to work in a team.
Right.
Because there's skills you learn there.
Yes.
That are going to help you all the way through life, whether you become a rocket scientist or a doctor or a policeman or any kind of job.
That's great advice, because even our world-renowned scientists, our engineers, they all work in teams.
Yeah.
And I would attribute my success at NASA. I've been a project manager to being able to understand people and figure out what everybody can do best. And if you can figure out what people can do best, you need to understand the technical side, but then motivate people, and you've got a success story right there.
Excellent. Do you have any advice for kids that are viewing here about how to take your job years from now?
Oh, okay. Well, I would love for kids viewing, so I'll look right at the kids. When you're in school, find something that you're passionate about, right? So it could be math, it could be science, it could be language arts, but absolutely follow your dream, be passionate about what you're doing, and don't go into something for just the money. Go into it for that greater purpose, something you wake up every morning, you're excited about what to do. And that's how I feel when I come to work. It's like I just look forward to each day, and that's what it's all about. You want to be able to do that and make a difference in the world, really. Make a difference in whatever you do.
Yeah, I've found that if you really like what you're doing, you'll do it well.
Absolutely.
And you'll give it the little extra time, you'll give it the little extra effort.
Yeah.
A lot of times when I go home, I'll dial some up on the computer about, I heard about this, I wonder what that is.
Right.
And you end up doing it for the fun of it, but
Yes.
you do it well and you have fun.
And you have to work hard. There's no shortcuts. You have to work hard. You put more effort you put in, the more you get out of it in anything you do, really.
Yeah.
And try to find that balance, right?
Yeah.
So I work at NASA, but I have a family. I have 3 children. I have a dog. I exercise every day. I try to find that balance and have fun.
Just for fun,
outside of
how did you come to work at NASA? How did you find NASA, or how did NASA find you?
I am one of these multi-generation families.
Okay.
My dad did work there.
Okay.
But when I was a kid, to me it was a totally independent decision, right? But when I was a kid, I loved airplanes. I loved rockets. I was pretty good at math and science. It seemed to fit, but I really wanted to help NASA discover new things. I mean, that's the core. And that's why I keep coming back today.
Excellent. All right, Ann, I want to thank you for stopping by
Thank you,
sharing
Tom.
sharing your experiences with us and knowledge about Venus and the outer planets.
This is great fun.
Hopefully, like we said, some kids will be inspired to come on out here. Let's take a look and see what's going on the transit.
There it is.
It goes kind of slow, doesn't it?
It does. I believe it takes about 6 or 7 hours to go across. And, I don't know if you heard earlier, but the cool thing is when you backlight Venus like that, you can see that atmosphere we were talking about, and you can actually get meaningful science data. And we have about 15 Earth orbiting satellites that are also very interested in the sun.
Excellent.
All right, so anyhow, so this is being viewed all around the world.
Yeah,
And-
I was telling people earlier that they want to see the view. This is the view from Cleveland.
Yes.
And it would be interesting for them to compare that against a view from one of the other sites. I think at NASA's website where this is being hosted,
Right.
you can pick and go to a couple other sites. You can go out and see what it looks like from Hawaii, see what it looks like from Cleveland. It'll be a little bit different
Yes.
every place you see it, and we're gathering as much data as we can on this thing.
And I don't know if you talked about it earlier, but for the kids that want to do a little math exercise, you can actually do some neat calculations. If you measure from other viewing locations, you
Yeah.
can get the distance from the Earth to the
Yeah,
sun.
I think that math was actually laid out on one of NASA's websites. I went
Yeah.
and looked at that.
Oh, good.
I have it in here somewhere in my
Yeah.
my
So-
bag of notes.
Right.
And it's using nothing more than high school math. It's using trigonometry, some sines
Right.
and cosines.
Yes.
And you have to put in a little bit of data.
Yep.
And in fact, if you're a good computer programmer kid, you could probably write a computer program to solve the hard math for you.
Oh, absolutely. Absolutely. Yeah. But we could sure use the next generation of kids. We're hiring people every day. It's a slow rate, but as I'm getting older too, and I would love kids to come replace me.
And I think Tracy is lining up some kids to. Are you lining up some kids to come in here and talk with us now? I think there's some
Okay.
kids that are queuing up over
All
here.
right, excellent.
If you wanna help them get in?
Sure.
Okay.
Sure. Thank you.
Bring them on in.
Okay.
Come
on
on
up,
up.
guys.
There
All right,
we
good.
go. This looks like a rocket
All right.
scientist.
Can you climb up there?
How
Can we
we
get
doing?
a 2-for-1 on this?
Hey, good.
Excellent.
Okay.
Okay. All right.
Gotcha.
I will turn this
All
over into
right.
good hands. With
Good. You want to hold the microphone yourself, or you want me to hold? You think you can do it?
Hold it.
Okay. Now there's a trick to it. You got to kind of point
Hello?
it at your mouth. Thanks, Ann. Thanks again. All right. And the sound is going to get picked. Have you played with a microphone before? Go ahead and say hello.
Hello.
Did that work okay there, Tracy? Oh yeah. Looks like your hello worked real good. Who are you? First name.
Mason, and this is my brother Owen.
That's your brother? And what'd you guys come out to see today?
Well, we come out to see Avengers.
Come out and see Venus, huh? Did you look through one of the weird glasses?
Yeah, but once we saw the kind of little dot, but my mom told me it's Venus coming up closer.
Excellent, excellent. Your mom must be pretty smart. She's helping you.
Yeah,
Helping you
and
out. Good
she's
deal.
over there.
Your mom's over there? Okay, we can wave to mom. That's good.
Mom, I'm on TV.
He's on TV. He's on NASA TV. This guy is excellent. So, what? You go to school yet?
Yeah.
What grade are you in?
First grade. He's in kindergarten.
Somebody's being loud back here. Got to talk a little louder. What grade? What grade?
First grade.
First grade. Okay. He's in kindergarten. That's a good job. So, did you have a hard year, first year of school, or was it pretty easy?
A little bit easy and a little bit hard.
A little bit easy, a little bit hard. That's the way school works a lot of time. A little bit easy, a little bit. Did you have any subjects you really liked? Must be
Recess and lunch.
Besides lunch. I liked lunch too. I thought lunch was one of the better classes. We used to have recess too. They let you go out for recess?
Yeah.
Yeah, it's good. How about science? You like science? Did they do any science?
Yeah.
Maybe a little writing and reading? Do you read pretty good?
Yeah, those are centers at my class.
You like to read? If you can read, if you're a good reader, we will be reading about you.
Wow.
You will become a very successful person, and we will read about you years from now if you're a good reader.
Okay.
Reading's the key to everything. And it's funny because you learn that in kindergarten, you learn that in first grade.
Even
And a
second
lot of
grade?
times when you're doing it, you don't think a whole lot about it, but really, really important. Does your brother go to school with you, or do you go to different schools?
We both go to the same school.
Oh, that works out good. You like having a brother?
Yeah.
Yeah, when I was young, I had a brother that was a couple years younger than me. Most of the time, he was pretty nice. Are you a pretty nice brother?
Yes.
Yes, I thought he was. Do you help out your brother at school?
Yes.
I knew he would. That's good. Brothers got to kind of watch out for each other, don't they? That's always the best part. I had to watch out for my little brother all the time. Sometimes that wasn't too good, was it? Yeah, sometimes little brothers get in trouble and then you got to get them out.
Yeah.
It's kind of fun.
Kind of like.
Is that another little brother?
Yeah.
Oh, cool. You got even another little brother. You're lucky. You're a lucky guy to have that many brothers. When you get old and want to play basketball, you got half a basketball team already.
Yeah.
You like basketball?
Yeah.
You looking forward to the Olympics this year? Gonna watch that?
Yeah.
Got to be careful this guy doesn't take a dive off the chair. It's kind of scooty there, isn't it? This chair's really up high. You got to be careful there. Don't fall off. Sit down there. There we go.
We want to be
We're
on
okay.
TV, Owen.
Just want to make sure he doesn't take a dive. That would be bad. We get the transit of Venus, and what's your name?
Owen.
Owen. We don't want the transit of Owen. That would be bad. So we're not going to let Owen take a transit here. Well, you guys have fun today. You got to remember this stuff. This is only going to happen once in your whole life. When you get old and gray and look like me and your hair's all going away, you're going to remember the day you came out here to see what it looked like, okay?
Okay.
So you have fun. Go over and look in the telescopes, and you guys have fun, okay?
Okay.
Okay, thanks for stopping by. You guys are good. Whoa, Owen's a jumper. Way to go, Owen. All right, let's get some other guys up here. Hop on up. And you are?
I'm Anthony Casto.
Anthony. Good man, Anthony. You like science and math?
Yeah.
What'd you come out here for today?
To watch Venus.
Venus, did you get to take a look at it?
Yeah.
What do you think?
It's kind of cool.
It's kind of cool, ain't it? What'd you think? Fast, slow, big, small?
I thought slow and small.
Yeah, it was kind of slow. A lot slower and smaller than I thought it was going to be.
Yeah.
It's kind of scary to think of how big the sun is then, isn't it?
Yeah.
Good grief. I mean,
Makes it.
yeah, Venus is as big as the Earth, and you look on there and it's some little speck like that.
Right.
That's kind of scary. We're out there all by ourselves floating through space.
Yeah. It is kind of scary. You look up, all you see is clouds, but
Yeah, just see clouds. Kind of cool. So where you go to school?
I go to Westrop.
Well, good. What grade you in?
5th.
5th. Oh, you're in the magic grade. Well, you're starting to learn some cool stuff, aren't you?
Yep.
What'd you learn this year?
Well, our teacher, Miss Kovach, which is very cool, she taught us how to make pop. She taught us how to make Rice Krispie snowmen. She taught us how to make our own toothpaste.
Wow.
She taught us a lot of good science stuff.
Could you send her over to NASA and let her teach me a few of these things?
I don't know, but she's probably going to watch this tomorrow over the PA, so.
Okay.
Hi, Miss Kovach.
Hi, Miss Kovach. Glad to see you. Excellent. You did a good job with this guy. Do you like science?
Yes.
What'd you do in science class? Did you do anything in science class this year? What kind of science?
We mainly studied Einstein's kind of inventions, rocks, and the lakes and pollution.
Oh, cool. So you were doing what we call natural science stuff.
Yeah.
Oh, slick. Did you like it?
Actually, yeah. The
Yeah.
limestone is interesting.
Yeah, it's weird stuff, ain't it?
Yeah. The
When
bottom of the lake.
you're in 5th grade, you'll be heading off to high school sooner than you think. When you get to high school, you're going to get a chance to take chemistry,
Yeah.
and you want to sign up for that.
My brother Johnny over there, he's going to graduate tomorrow from 8th
From
grade.
high school?
No, from
Oh,
8th
from
grade.
8th grade.
He's going to Rhodes.
Oh, he's going to head off to high school.
Yep.
High school's cool. But I'll let you in on a little secret. If you want to do good in high school, you start doing good in 5th and 6th grade. Especially science, math, English, stuff like that. It's going to kind of build. They're going to build on what you learn. This summer, you can't forget what you learned last year.
Yep. Brought home the math book.
You brought home the math book. This guy's after my own heart. You like the math?
Actually, yeah.
It's kind of fun, isn't it? It's kind of like doing puzzles.
I like add and subtract fractions the most.
Oh, that's a tricky subject. Adding and subtraction fractions is kind of tricky, isn't it?
But my best thing is music, which is going to get shut down next year. I'm in the ensemble.
Oh, that's too bad.
Yeah.
Well, and I'll tell you something. A lot of guys who become scientists or engineers study music. It's sort of good for your brain, teaches you discipline. You have to practice a lot, don't you?
Yeah.
Do you practice a lot? What do you play?
Oh, play? I sing it.
Oh, you're a singer. What's your voice? Soprano, alto, tenor, bass?
Mainly bass.
You're a bass. Good man. The guy sings bass. Papa sang bass.
That's my dad.
That's your dad?
Hi, Dad.
Does Dad sing bass also?
No, he's not a singer. He's a game player. He plays Modern Warfare all day.
Oh, does he?
Yeah,
Can he carry a tune?
probably.
Singing's kind of a cool skill.
Yeah.
You keep working on that, and you learn to work together. When you sing in ensemble, you got your part to sing, and then somebody else
Yeah.
sings their tenor part against you, or the soprano will sing something.
Yeah.
I'm a singer too. I sing a little tenor and a little bass. At
Why don't you
church
sing a
and stuff.
tune?
Okay, what do you want to sing?
Oh, we're both gonna sing.
Well, I don't know. Maybe you sing.
What about you sing first?
What about you sing first?
Yeah, I was just at the Rock and Roll Hall of Fame today. No, not today. I'm sorry. Like 2 weekends ago.
Yeah.
The Rock Your World team.
Okay.
I went to the Science Center. Cool stuff there.
Yeah, cool stuff there. Did you go to NASA's part in the Science Center?
Yes.
Yeah, it's kind of cool. The Great Lakes Science Center's in downtown Cleveland, and it now houses NASA's Visitor Center. So people used to come out to NASA to go see spaceships and stuff like that. They can go to the Great Lakes Science Center and see that. You got to do that.
I like that old, like a ship that was like, it was circular.
Oh, yeah, the Apollo?
Yeah.
Yeah. Did you look inside there?
Yes, it was creepy.
Yeah, wasn't it creepy? Would you like to put 3 guys in there and fly all the way to the moon in that thing?
No.
No.
I mean, if I was getting good money for it, yes.
Oh, okay. Got to give you good money. All right. Well, we're going to bring your brother on up here. Is this your brother here?
Oh, I
Sorta
don't.
looks like
no,
it.
I don't know him.
You don't know him? Never seen him?
Honestly, he's
I
not my
think
brother.
he's going to fight you for the microphone, okay?
All right.
I want to thank you for stopping by.
Have a nice day.
Okay, you do too. Hop on up here, brother. Are you the brother that's getting out of 8th grade?
Yeah. No, I'm not into that school. I'm in the 7th grade.
You're in the 7th grade.
Yeah.
Excellent. And your name is, first name?
Austin?
Austin. Austin, you. Kids? Son, what does that mean?
Sun.
Son.
Look up at the sun
Should you look at the sun?
with the...
Only with that, right? We've been warning people today. Oh, here we go. We're looking at the sun. We're
That is-
showing the sun here.
that
Do you
is-
see that little dot?
Yeah.
What is that?
Venus?
That's Venus.
It's very small.
Yeah, it's kind of moving around, isn't it?
Yeah.
It's not moving very fast, though.
Is this supposed to go down at an angle or straight across?
Well, it's supposed to kind of slide off on one angle.
Oh, okay.
Okay, and I'm not sure which angle because we didn't get the pictures up here. I think it's going to slice off on this monitor, kind of from upper left to lower right. I think it's going to slide across like that. It's kind of cool if you go to different places on Earth, and you look at that. It'll be in a slightly different location,
That'd be...
and you can use math and actually figure stuff out about how far away the sun is using that. Kind of wild. It's math that you're studying already in 7th and 8th grade.
Yeah.
You like math?
It's okay.
It's okay, not your favorite?
Yeah, not my favorite.
Not your favorite? It's not everybody's favorite. To be real honest, a lot of times math's not your favorite because you haven't seen how they use it. If you can just hang tight with it, when you get in high school, they're going to show you some more parts to math, and then it starts to make sense. One day, kind of the light goes off about, yeah, that's kind of slick what that guy did with that. And somebody able to calculate out something like that, or solve a problem, or figure out what the volume of a certain weird shape is, or something like that. You'll figure it out. Just kind of hang tough. Don't give up on math yet, okay? What's your favorite subject in school?
Visual art.
Visual art.
Yeah.
Okay, that's kind of cool. Yeah. Do you paint?
I draw still life. That's my major.
Excellent.
Yeah.
Oh, how cool. Where'd you learn to do that?
I just started teaching it to myself.
Oh, excellent. You know, a lot of still life stuff's kind of interesting because you end up with a lot of geometric shapes.
Yeah.
Have you done some studying about that, about how to draw a sphere, how to draw
Yeah,
a
we
cone?
just did the sphere for our finals.
Oh, cool. And
So-
you learn about shadowing and stuff
Yep.
like that?
I have a picture on my phone of the one that I just did.
Excellent. You got your phone here?
Yeah.
Let's take a look. I don't think we can share it on television here
Oh.
because I don't think they can zoom in close enough. Oh,
Yeah.
that is too cool.
Yeah, that's the one. That's a spear done in charcoal.
Excellent. I wish you other people could see all this stuff. That is pretty slick.
Yeah.
You've got a good eye for that.
Thank you.
And having a good eye is, again, part of kind of science. You'll find out there's a little science and stuff like this as well.
Yeah.
If you look at that guy and look at the sun, can you see that dot as well as we could on the?
Slightly.
Yeah.
Yeah.
I didn't get a chance. Can I borrow your thing? I didn't
Yeah,
get
go
a
ahead.
chance to take a shot at this. Boy, you got to be good to see that.
Yeah.
You got to have good young eyes, not
Yeah.
old eyes like mine.
Yeah. See, there it goes again.
Oh, there it is. Yeah. It's so close to the edge, it's kind of hard to see when you look at it with one of
Yeah.
these viewing glasses. But it's kind of cool. Again, we want to warn people that are listening on the web, do not look at the sun with your unaided eye, right?
It would hurt.
Why is that?
It would hurt.
It would hurt. My artist guy here with the good eyeballs, you know enough to protect your eyes and stuff. Cool.
Yep.
Very,
I learned
very
my
cool.
lesson.
Okay, good job. Do we have anybody else here, Tracy, to come in and say this? We got a couple other more kids. I want to thank you for stopping by. Did you have fun today?
Yep.
It's kind of slick stuff.
Have a good day.
Good man, you too. Thank you. Bring on the next kid. Whoa, hop on up there. Oh, we got two kids. Very good. And we'll let you pass. We'll let your older sister here. You get to fly the microphone for this guy, or we'll share.
Okay.
And you are first name.
I'm Juliana.
Juliana, and who's your buddy here?
I'm Justin Watley.
Justin. All right, cool. And what'd you guys come out to see today?
The sun thingamajigger?
The Venus passing the sun.
What'd you think?
I thought it was kind of cool, but I could barely see it.
It's hard to see. Oh,
Yeah.
good. I noticed you're wearing glasses. I thought it was just me.
Yeah, I was like, where
I'm
is
kind of
that?
squinting, and I think if somebody wouldn't have told me it was there, I wouldn't have known.
Yeah.
I think it was kind of cool because it's like a little dot, but in space it's like huge.
Yeah, it is huge. You know about how big it is?
I think it's like my grandmother said that it's bigger than Earth.
Actually, it's just about 400 miles smaller than Earth in diameter. We're the big guy. We're the big guy on the block, but it's almost like our twin sister.
But when I was looking at her, I could barely even see it. It was just like a little shadow. I was like, we came all the way down here for that little shadow?
Now, why was it so small?
Because the sun is really big. So
Really big.
it's just
because the sun's really big and it's no size nowhere near compared to the sun. And
yeah, I learned that
and-
there's 100. You could put 109 Earths in the sun, like across the sun.
Oh my gosh! Just to
Yeah.
go across.
Yeah, just to go across. Like if you had a whole bunch, just go straight across.
I think it was small because it's not as big as it is in space because we're not seeing it from up close, just like planes when they're in the sky.
That's right. We are. Do you know how far away we are right now? I don't
No.
know if anybody told you. 25 million miles away.
From space?
From Venus.
Whoa.
The difference from the space from Venus to the Earth is about 25 million miles today, and that's as close as it gets. It's going to get farther away.
Oh, wow.
Yeah. Space is big. Do you guys like to study about space?
Yeah, we've been studying about space at school for 7th, 8th graders been studying about it for 2 trimesters. So
We've been trying to learn every planet in space, and I think I got it down.
Can you name them all?
yeah, Mercury.
Shall we put this guy to the test? What do
I
you
can do it.
think? All right, here we go. Big test. You ready to go? All right, here we go.
Mercury, Saturn, Venus, Jupiter. I forgot that Pluto wasn't a planet anymore.
Close.
And what else?
The 2 big
I can say
gas
them in
giants.
order.
Oh yeah, the 2 big gas giants, the moon, and the no, I'm just playing. The sun, and there's the what else?
I think sister
think-
can do them.
Yeah, I
do
can
them,
do it.
sis.
Okay, it's Mercury, Mars, Jupiter, Saturn, Earth, Venus, Neptune,
Neptune, you missed that one. That's good.
and
The one that starts with the U.
Uranus.
Uranus, that's right. Very good. You win the prize. Excellent. Did you guys have fun at school? What's the prize? Oh, I wish I had a prize. We don't have a prize. Looks like somebody's sneaking up behind us there. All right, yep. Got to stay right on the camera there. You see yourself there?
Oh, yeah.
Yeah, there you are on the monitor. Kind of cool.
Um,
So you had fun at school this year?
yes.
No. Why not?
I mean, the teachers are whatever. I mean, the kids are cool.
Kids are cool.
and, Yeah, they get along good, but the teachers are a different story.
My teacher is one of the best teachers in the school because she doesn't yell that much, and if you mess up, other teachers are like say that's wrong and stuff, but she'll put you up and say it's okay, you can try better next time.
You know, it's kind of funny. I think we all mess up in school every once in a while. I used to
Yeah.
mess up in school.
And
But science and engineering in particular, when you mess up, that's okay. You learn something sometimes when you mess up. It's no big deal to mess up once. You know what the trick is? Don't do it again. That's the secret.
Don't make the same mistake.
That's the secret. Don't make the same mistake. Right. Making mistakes, there used to be a trick about people that don't make mistakes, don't make anything else. If you're not willing to try stuff and see what happens, you're not going to learn. But you don't do it more than once. You don't want to do the same mistake over and over.
my teacher, she was supposed to be her teacher because she's in 7th grade and I'm in 4th grade.
Yeah, she was supposed to be our teacher, but then we got a new teacher, and his teacher quit, so then they just put him down.
Quit, so
Oh, that's too
her
bad.
The teacher that was supposed to be in her room moved down to my class. So the teacher that she was supposed to have is now my teacher.
Okay.
But
Well, that happens.
I would
They
have to
move
say,
around.
The 8th graders are graduating tomorrow, so I have to say that's the worst part of the school year, because to see them
Well,
leave-
you're in 7th grade now, right?
Yeah.
That means next year you're 8th grade.
Yeah.
That's the top of the pile. It's going to be real important. You'll have to be the leader next year.
Yeah.
It's lonely at the top. People are going to be looking up to you to do the right thing.
All the way from kindergarten.
Okay. Are we ready to bring Roger in now? All right, good. I want to thank you guys for stopping by. You have fun this
You're
summer.
welcome.
And keep I mean, this is just the start. Transit of Venus is one thing.
16 with
Mercury's going to pass. It's going to be kind of cool. And we're going to be landing a ship on Mars this summer.
People
It's
are going to be
called-
in it, or just
Oh, no,
a trip?
it's going to be a rover. It's called Curiosity, and it's going to be about as big as that SUV. We're going to parachute it down onto the surface of Mars. It's going to have a nuclear power plant, and it's going to drive around, and it is going to be really exciting. So be sure and watch for it, okay? Be ready to go next year when you get back to school.
Wait, how is there a spaceship that big?
Oh, it's a big one. It's on its way to Mars right now.
Are you guys not sending any more people up in space?
We got 2 people right now up in space. They're Don Pettit and Joe Acaba right now are up on the International Space
Bye.
Station. Okay, bye guys. Thanks for stopping by. Here we're looking back at the transit of Venus. and it's moving along quite a bit better now. It's way off the limb. Goes slow. Okay, he's getting ready to go in the.
It's beautiful.
Yeah, it is kind of cool, especially since it's the last time we get to see it. Joining me here when we come back from looking at Venus is Roger Dyson. And it's good to have you. Thanks for hanging around this long.
Oh, absolutely. Wouldn't miss it.
That was a tough act to follow.
Oh,
those
yes.
kids.
Yeah. I don't have a chance. This is great.
But this is great. This has been kind of fun.
my gosh.
And you are probably more interested in Venus than a lot of other people here in the city of Cleveland, right?
Been studying it for several years, trying to find ways to go back to Venus and survive on that surface. As beautiful it is here, it'd be a challenge to live there and be there. So yeah.
We've kind of hinted around about a lot that, but from the people that I knew I was going to be talking to today, you're the expert. So would you like to tell the people a little bit what it's like on Venus?
Okay.
And then how we even practice that, or how we simulate
Yeah,
that.
sure. Well, Venus is perhaps the most challenging, hazardous location in the solar system to do exploration because the temperatures, the high pressures, the hazardous chemicals on the surface are unlike anything anyone's ever seen on Earth or any of the conditions on Earth. It's hot enough to melt lead. It's 92 times the pressure of Earth, which is the same thing as going about a kilometer or almost a mile into the ocean. And the chemicals on the planet are very dangerous to people and materials and landers. So a large part of what NASA has been doing in the past several years is trying to develop technologies that can survive on the surface. And as a part of that is we've had to develop a means for simulating the conditions of Venus. And we have a large environmental chamber that's coming online in the fall, and maybe you've seen it in the news recently. It's very unique. It's a very large chamber. It's 3 foot in diameter, 4 foot in length. It's large enough to put an entire lander inside of it. And what's really interesting about it is that it can simulate all the altitudes of Venus. It can simulate all the different conditions of Venus, which is important because all the missions that have been flown here over the past 30 years, the last one was in 1984, and it only lasted 127 minutes on the surface. And it's thought that even just going through the sulfuric acid clouds on Venus, that can damage your lander. So we've designed a chamber that can simulate from the vacuum of space all the way down to the high pressures and temperatures on the surface to test our new technologies.
I think they were showing some figures, some pictures of your facility. Can you see that on the monitor? You want to describe that?
Yeah, that's that large chamber I was referring to earlier. It's 3 foot diameter, 4 foot in length. It's made out of stainless steel and special metals that can resist the chemicals that are found on the surface of Venus. And if you look in there, there's a lid laying on the ground. It weighs 7,000 pounds.
Oh my gosh!
It's a foot thick, and it's designed to hold 1 million pounds of force.
Oh my gosh!
Each of those bolts, if you look on there, weigh over 100 pounds. There's 22 of those bolts, specially made for this project. And you can see it's very large. A person can easily fit in there. It's designed to hold a whole lander. And yeah, we're really excited.
How do you seal that?
Well, with those bolts, there's a ring. If you look in the box there, there's a very thick ring.
Oh, I think I see it right down in the bottom.
That's right.
On the bottom left, kind of sitting on top.
Sitting on top of the lid.
Okay.
That ring goes in a groove, and then you put the lid and you compress that ring, and then that ring holds those extremely high pressures.
Oh my gosh.
Yes.
Those are O-rings, right? Us NASA people.
Those are metal O-rings.
Okay.
Yeah, metal. It has to be metal because of the high temperatures.
Oh, I hadn't even thought of that.
That's
yeah.
right.
And then you put crazy chemicals in there too, besides high temperatures and high pressures, right?
We put sulfuric acid. We put flammable chemicals. We put every chemical you can imagine goes in there.
How do you keep the facility from melting, or how do you keep the facility from melting or corroding or rotting away?
Well, inside the chamber is a liner.
Okay.
And the liner is a special metal. It's a nickel alloy metal.
Okay.
We had to do that because no one in the world has ever put all the chemicals of Venus in a oven like this and cooked it. And so no one really knows what materials are how they're going to react.
Oh, fascinating.
Yeah. So this liner is designed that, let's say 3 months from now, after putting these chemicals in there, it starts corroding and falling apart.
Okay.
We can pull that liner out without destroying the entire facility.
Ah, very clever, very
Yeah.
clever. So you let the big metal on the outside take care of the pressure, and the liner takes care of the corrosion.
Exactly,
Okay,
exactly.
very, very clever.
Yes.
Who figures all that stuff out?
We have a whole team of people.
Okay.
There's actually been about, I'm going to say 45 people involved in the development, design. This whole thing got started because 4 years ago, there was a Venus flagship mission that was being developed and proposed.
Okay.
And we wanted to go back to Venus in a big way, surface missions, balloon missions, orbiters, and so forth, for a flagship mission. But one of the first things that was realized was that, well, if we're going to go back there, and if we want to stay there for longer than a few hours, we need to find a way to test these things in a full-scale environment.
Okay.
All of the previous missions that have gone to Venus were not tested in a full environment like this.
Yeah, this sounds like a new facility.
It's a completely new facility. In the past, people would just use nitrogen, and they would go to the pressures and temperatures, but they wouldn't include all those chemicals. But those chemicals are the problem. Yeah.
Okay.
Yeah. They limit your survivability of your lander. Yeah.
Now, the other thing you were talking about is inside of that, you said the word cook.
Yes.
And I've heard that inside that big tank, it's on the order 900 degrees Fahrenheit.
900 degrees Fahrenheit, enough to melt lead.
Okay, so when you're on the surface of Venus, it's 900 degrees Fahrenheit on the out. How do you keep anything alive?
Well, as of right now, the only way we know to survive there's two ways. You either basically bring ice with you.
Okay.
And you let the ice melt. It's not made out of water, but it's a similar material that melts. Once it's done melting, you're done. And that's why vehicles last only for a few hours.
Okay.
Your only other option is what's called active cooling. It's basically a refrigerator like you have in your home. Okay. But rather than using electricity to power it, we use a nuclear or radioisotope heat source to power it.
Okay.
All right.
Okay.
And we basically have a 3-foot diameter refrigerator. So you put all of your electronics, all of your sensors in this refrigerated area, and it cools it to the same temperature as Earth. It's about 30 degrees Celsius or room temperature.
So that simplifies the design of your components.
Yes.
They could work at Earth temperatures,
right.
But then you've got to rely on your refrigerator unit to work perfect.
Right.
And how do you test that?
In this large chamber that we have.
In the facility, right.
Exactly, yes.
Oh, how slick.
Yes.
Are you guys going to be doing that?
Well,
you said the facility's coming online. I wondered what the plans were.
Yeah, well, the basic plan is this, we have the facility coming online in the fall.
Okay.
Okay. Now, we have numerous outside customers that are going to have their items ready to be tested before we will.
Okay.
We have designs right now, but we don't have any of our hardware. We just basically had about a year to do our design. So we're going to be probably 2 years from now before we can test our refrigerator type of system in here.
Okay.
Okay. But other groups are going to be testing things like, for example, instead of using a nuclear heat source, which we'd rather not use nuclear if we don't have to.
Okay.
Okay.
Yeah.
And they like to burn lithium in the atmosphere of Venus. And if you do that, it's like having a campfire on Venus, but rather than burning wood, you're burning lithium.
All right.
And the lithium burns the CO2. It uses the CO2, the carbon
that's
dioxide.
That's its oxidizer.
All right.
Okay.
And if you do that, you can have a mission survive for 5 days.
All right.
Okay. Now that's much better than the 3 hours.
You betcha.
Okay. And the 5 days, possibly 10 days, you can do that with a fairly small lander.
Okay.
And so you use that heat then to power your Stirling engine, which runs your refrigerator, which still keeps your area cool. So we can do that in a fairly short time. That'll be one of the first things that we're going to be testing next year is this lithium combustor.
Okay.
Yes.
To see whether it burns in the carbon dioxide at those pressures I would think that there probably isn't a great big database about how materials burn at those kinds of pressures, at those kinds of temperatures.
No one has ever included all of the chemical species that's on Venus.
Okay.
Okay. It's you're crazy to try to do it
Right,
generally.
right.
Okay. But if you're going to do a mission, you got to do crazy things.
That's right.
So yeah. So no one knows for sure. You know, we're 99% sure we're going to do this and it's going to work. Okay, but that's why we're testing it.
Right.
Okay, and if it doesn't work the first time, we'll find a way to make it work. But the important thing is that we will have all of the chemical species, meaning the entire atmosphere of Venus, in this chamber, so we can see if that lithium really does burn the way we think it's going to burn.
Okay.
Okay. Yeah. So that's the idea.
That sounds like fun.
Yeah.
You seem like you have fun with this stuff.
We do. Yeah. I can say that it's not hard finding team members. All I have to say is really challenging problem. Venus, very close by, something you can see with your naked eye, and it pushes all the technologies. You have to go to extreme temperatures, extreme pressures, extreme efficiencies. That's something else I haven't mentioned. Everything about it is extreme.
Okay.
That's why we call our chamber the Extreme Environment Chamber.
The Extreme Environment Chamber.
Yes.
Cool.
Yeah, it's the most extreme place in our solar system, and we're learning now about some of these exoplanets, which have also potentially very extreme environments, and we can model those as well in this chamber. Yeah.
Could you use that kind of chamber to model something we do here on Earth in an extreme way? Like some kind of a super jet engine or a burner in a hypersonic propulsion system or something like that.
Yeah, you got some great ideas there. Yeah, no, actually, yeah.
See what happens? Somebody comes in with a good idea and it tickles somebody else.
Absolutely. Yeah, so, no, actually, the Venus is very much like the inside of an aircraft engine.
Okay.
Okay, which is also why, our center has a lot of technologies that are suited for Venus because we have a long heritage of working with aircraft.
Right. Well, we had Gary up here
Gary was
earlier talking about that.
Yeah. So absolutely. In fact, we had one group asking about filling it up with water at high pressure because they'd like to be able to test ramjet torpedo propulsion systems.
Okay.
So you can also deep well drilling in our for oil.
Right.
You're getting closer to. It's actually not as hot, but same pressures, sort of high temperatures. Volcanoes, another area. Okay. So a lot of these technologies can be used. That can be tested. Also,
you could study magma.
You could study magma. Right. All right.
I just want to say magma.
You can also make aerogel in this thing. You can treat it like an oven. Turns out aerogels like to be at these really high pressures and temperatures. So yeah, no, it's anything that's extreme. Yeah.
Okay.
Yeah.
And that's, I guess, another kind of cool thing about working in a research center like NASA Glenn. You build something maybe for one idea, and suddenly all these other areas open up.
Yes.
That you can do it if you've got the first facility. I mean, somebody's got a honcho, and somebody's got to be an advocate, and somebody's got to be a design, somebody's got to be the principal investigator on something like that.
Right.
And that's you.
Right. Yes, actually, doing something for the first time like this, first everyone says you can't do it.
Right.
And then you have to find a team of people who, maybe believe that you can do it.
Right.
And then they spend the time exploring all the objections to it. And then finally, we can do this.
Yeah, and then it's, why didn't we do that earlier?
Yeah, what a great idea. Yeah, exactly. But now, in fact, those pictures that they were showing earlier, we've waited 2 years to reach that moment, and it just came here a couple weeks ago. So
and that's I think another one that students or kids that are watching this broadcast should know is that engineers and scientists like you and me, you don't have gee whiz ideas and run off and do them in a week or a month or a year.
Right.
Normally the victory goes to people that hang in there and really believe in what they're doing and solve all the problems along the way.
Perseverance and patience.
Perseverance is the key. I think Thomas Edison said something about that one time, about creativity being mostly a perspiration, not inspiration.
Yes.
That you've got to do the hard work and you got to stick with it.
Yes.
Although it's hard work's kind of a weird phrase because I don't think you or I think of this stuff as hard.
No.
In the sense that we don't want to do it or you back away from it. It's kind of like it's hard. Let's get in and
it's like a good game. You want to win. You want to win the game.
Yeah. It's a good puzzle.
Yeah.
You go home at night and you normally I'd have to say 2 or 3 nights out of 5 I'm frustrated. Something didn't go right.
But at least that many.
Yeah. But then you have those nights of we're a little bit farther along, or this guy's coming together, or we're going to be able to do it.
Yeah, well, and it's also exciting to watch the public's reaction. All we have to do is show them this, you know, and they're like, really, you can do that on Earth, and that's possible, and people are proud of that.
I've got to do an admission on this one because I only met you a couple weeks ago on this stuff, and I didn't know about this. Hello there. But I find it absolutely fascinating. This is one of those cool things that I didn't know was going on at the lab. But it's just an incredible piece of technology, and you're to be really applauded for this. I mean, for owning it, for staying with it,
Well,
and it's fun stuff.
I don't look at it that way.
I know you're a member of the team.
Yes,
I mean,
yes.
Ann was in here talking earlier about how everything we do in teams.
Yeah.
And
if one person wasn't doing their part,
that's right.
This would not happen.
That's right.
Yeah.
But students should know about that as well. There's a lot of teamwork skills that you have to learn to do that as well. So you've got the facility coming online. You got some tests going in there. What's your next challenge?
Well, interestingly, as a result of developing this technology for Venus, we had to develop a very efficient power system.
Okay.
And I can't disclose the company name.
Okay.
Okay. But there's interest in commercializing this technology and putting it in people's homes.
Fascinating.
Okay. Yes. It turns out that because we had to make the world's most efficient engine, people would like to use this in their homes.
Okay.
And the idea is you can produce electricity in people's homes. Okay.
Fascinating.
So we have outside investors funding NASA to develop this. But again, I can't go into all the details.
Okay,
It's
sure.
proprietary.
No,
They're
understand
paying
how
for it.
that works.
Yeah, but we're open to any other companies that want to, benefit from some of these ideas. This is perhaps one of the best stories about NASA and about our technology is that it applies to Earth. I mean, you can see today just the fascination. I mean, everyone's here because they want to be here.
Yep.
All right. They're not here because NASA's here. They're here because this is just really cool stuff. Okay. But also, we work hard, and like you said, we stick together as a team. We love the challenge, but it's the challenge. It elevates the national mood, but it also has serious commercial applications all over the place, and this is no exception to that. And I know, talking to my NASA guys on my team, when you can talk about doing something for the first time, such as the Venus, and then you can say, and also you can use it on Earth to help our energy crisis. That just gets that you can't get any more exciting.
That's right.
Than that.
That's right.
Yeah, you're at your peak there, and I mean, in fact, I have to yell at the guys. Don't come in on your vacations. Your weekends, you should stay with your families.
Yeah. There's fun sometimes. I talk to kids a lot, and there's sometimes when I'm in the midst of doing something, and I kind of you take a step back and you say, and people pay me to do this. This is just absolutely mind-boggling. Now, there was a lot of work had to be done. You got to do well in high school. You got to do well in college. A lot of nights doing homework and stuff. But there's a tremendous payoff for any of these kinds of things in science and technology, particularly at NASA. We just get to do really cool stuff. And we'll keep doing cool stuff as long as people want us to do it.
As long as they'll let us do it, and
as long as they'll let us do it, as long as Venus is up there.
And I don't think everything's been invented yet.
Oh no!
So
Yeah, we were talking to kids about that a little bit earlier. That particularly in stuff that has to do with outer space and the like. You're a little younger than me, I believe, but when I went to school, nobody knew about black holes. Nobody knew about dark matter. Nobody knew about the Kuiper Belt. Nobody knew. I mean, the lists of things that people just did not know about are sort of standard things that people worry about and study and really just have a ball doing now.
Yes.
So there's lots of stuff out there still to be done, and we need young, bright people to come in here. Join your team or join my team.
No, my team.
A little competition is good. Roger, I want to thank you for stopping by.
Absolutely.
Excellent story.
Okay. Thank
All
you.
right, we're going to go see what's going on up on Venus, and then we're going to bring in our next guest, and our next guest is going to be Clyde Simpson from there's the clouds are coming in. Either that or Roger's made a real hazy day in space. We can see that Venus is moving along a little bit. Can you see that, Clyde? It's kind of cool.
Oh, beautiful view.
Yeah,
absolutely
I think
gorgeous.
It's a little bit better view than sitting here with a piece of plastic over here. At least with eyes of my age.
It's a little easier, I'd say, yeah.
About the only way you could see that better would be to use a big telescope, right?
Well, pretty much, although we've got a lot of big telescopes around here, so everyone's getting a really fabulous view of the planet.
And as you come back to me, you coming back to me, TV? Let's see whether they come back to me. Yeah, they're coming back to us. Good.
All right. Yeah,
this is Clyde Simpson, and you're with?
I'm the observatory coordinator at the Cleveland Museum of Natural History.
Okay, cool. So you are an astronomer. We had a couple of engineers, scientists, lots of kids.
Yeah, right.
And you're an astronomer.
Well, I look at the stars, yeah.
You take a little different view of the activities today, or you got a special perspective on this? Or what do you think?
Everybody's excited. This is the last time any of us are going to see this again, so yeah, I'm exceptional. With all of the astronomical community here in greater Cleveland area to bring out telescopes, observing viewers, and join the astronomical community to celebrate this fabulous event.
It's cool.
But I do want to invite people to come back to our observatory because we've got a rather substantial telescope at the museum. It's open on Wednesday nights, September through the end of May. Unfortunately, it gets dark so late in the summertime we don't have summer hours, but 8:30 to 11, fall, winter, and spring, come on down and look through our giant telescope. The other great thing is we've got a planetarium at the museum.
Okay, and again, for kids that don't know or have never been there, planetarium's a little bit different than a telescope.
The observatory has a dome, the planetarium has a dome. The observatory dome opens so you can see through the telescope. But the planetarium has projectors, so it simulates the evening sky. We show all the stars, constellation patterns, and talk about any variety of astronomical subjects, including through the end of June, the transit of Venus, talking about the scientific value of observations of the transit of Venus, historical value to it. And our planetarium is open every day, and on weekends we have multiple programs. So.
It's fun when I'm kind of an amateur astronomer.
Right.
I belong to Cleveland Astronomical Society.
You're
and I have my own scope.
Advanced amateur, yeah. Tom,
no, I'm an amateur.
You're being modest.
I'm an amateur. But I've always had an interest in that. I mean, even though I went off into NASA and aerospace engineering and the like, I think my interest was triggered when I was young, just sitting out in the backyard on a summer night and staring at the sky.
What an easy hook. Who doesn't love looking at the stars, right?
Exactly. And as you said, there's this historical perspective to all this of people, as long as there have been people going out, looking at the sky, noticing things, trying to figure out what's going on.
Yeah.
And then developing, again, we were talking about engineering and developing the technology to let you do that, which is where telescopes and planetariums and the like come in.
Absolutely, and the mathematical precision by which you can precisely predict when these things are going to occur, that just always stuns me. You know.
Yeah.
To the second we were able to see Venus enter the solar disk.
Yeah, that was pretty wild when
pretty
you think about it.
Interesting, yeah.
And who predicted it and how did they predict it?
Well, we've been looking at the motions of the planets. You know, what was amazing is the Mayans used Venus for their calendar and predicted with greater accuracy than even up till the modern calendar. They didn't predict transits, though. That was a curiosity. They had its orbit down really well. They knew the variations of its path, but they did not make any mentions of transits.
I wonder if that's because Venus, I mean, it's kind of funny looking at it here today, even with the darkened glasses and the like.
Right.
It's hard to see.
Oh yeah, without proper shielding.
It's easy to see when it's away from the sun. I mean, when you're just out there, it's the brightest thing in the sky.
Next to the sun and the moon, yeah.
And so there's this kind of, I guess if you were a Mayan and you were stuck with just what you could see visually, and record data on that, I assume they did a rough method of scientific observation, take data, record data,
Absolutely.
make predictions the same way all scientists do.
Base their entire calendar on the 584-day cycle of Venus returning to the same part of the sky, just continually. Just, with calendars going back thousands of years and thousands of years into the future, which tens of
Shall we breach the topic? Shall we
why
talk
not?
about the topic?
Why not? Tens of thousands of years into the future, they've got calendars predicting. So there's no Mayan tradition of the world coming to an end, transforming, doing anything on December 21st of this year.
Okay, you heard it here. When we rebroadcast this broadcast, we're going to put this on a loop. You heard it here from a real scientist and a real astronomer. The world does not end in December. Keep going to school. Keep doing your homework. Don't get in trouble. Don't run up big bills. The world will continue.
I'm completely confident of that. I'd like to meet up with the dozens of people that have written these books the day after and say, okay, what are you going to do with your money? Because I think that's probably more often than not why they're in that game.
Yeah, it's kind of fun stuff. So, it's interesting again that you have your observatory open for the general public to come out and see that stuff.
Correct.
I live right near. Oh, there's your.
Oh, yeah.
There you go. We've got a figure up right there. What are we looking at?
That's our planetarium from the exterior, and it's a unique design that tilt points right up to Polaris, the North Star.
Oh,
so
cool.
It's the first planetarium built that's actually an observatory in itself. If you stand in front of it and look along that line, that'll take you to Polaris, the North Star, the only one that never moves.
Sort of like modern Stonehenge.
Exactly. And there's our telescope, built right here in Cleveland by Warner and Swayze in 1899. It's a 10 and a half inch diameter refracting telescope, but it works just as perfectly today as when it was built. There's no finer 10 and a half inch diameter telescope in the world. And that's the one we invite you to come and look through personally on Wednesday night, September
So anybody
through May.
in the Cleveland area or people visiting Cleveland,
Correct.
if they come out on a Wednesday night in the fall or whatever,
Yeah,
they
September
can come
through
right
May.
on out and take a look at this.
Absolutely.
Oh, it's incredible.
And I gotta
you
mention,
could have this kind of fun once a week.
correct, except at night. Yeah.
Except at night.
Right.
Even more fun.
And Baldwin Wallace, I got to put a plug in for them. They've got a wonderful Warner and Swayze 13 and a half inch diameter telescope, which is even a little bit bigger than ours, and they have regular.
I have actually
viewing.
looked through that one. I know Jerry Crater.
Exactly,
And Gary Crater. And I live in Berea, which is a suburb of Cleveland, where Baldwin Wallace College is. Cleveland's kind of an interesting place.
I love
for the
it.
number of universities
Entirely.
and the number of people.
My son's going to Baldwin Wallace right now.
That's
hey,
right.
Did you see the sun?
How you doing? Yeah.
Did you see the sun through the welder's glass yet?
No, I haven't.
This is the best way I like of viewing the sun. It's a number 14 welder's glass.
Okay.
A cautionary note, if you ever use welder's glass, it has to have the number 14 on it, as you see clearly there.
I see right there, yeah.
Any number lower than that is not going to be safe. This removes all of the infrared and the ultraviolet light that would endanger your eyes.
Okay, so I can use this?
Right. Well,
bad thing is we got the sun in a tree.
Once the tree goes away. Let me give you a piece of advice when you use that, though, a little technique.
Okay. Let's see.
You have to hold it by the edges, because if you smear it, right.
Like
but
a CD.
A lot of people are tempted to look at the sun and then put it up against their eyes. By that time you've already got maybe damage on your eyes. So what I do is I put it up against my eyes, and then with a graceful sweeping motion, then you look at the sun, and then that's safe to observe.
I hope everybody was listening to that out there. This is the way to do it safely.
Patented technique, and I had some specially made, a friend made some special number 14 welder's eyeglasses, which are going to be all the fashion next time we have a total eclipse of the sun. Try it out. You're going to love these.
Where did the world go?
Oh, Tom, that is you.
Is this me?
That's great. But those are special.
I was going to say all I can see is things behind me. This is like having mirrors on your car. I think I could be an Indy racer with one of these.
Only in full daylight. Except the sun.
Is the sun.
That's the point.
Incredible. You astronomy guys have too much fun,
You're
you know?
right, we do.
You do. And how would kids, what should kids do if they want to grow up and have fun like you? What should they do?
You know, obviously you've got to do pretty good at school. You want
Okay.
to study. To get into astronomy, you're going to need your math. You're going to need your science.
Okay.
If you're not really interested in that at an early age, that can come later, you know. But I
Okay.
think the most important thing that I can tell any kids out there is to read. You know, read, just from the beginning. You can pick up all of that other stuff as you go along, but read comic books, cereal boxes, read books, read magazines, just read as much as you can.
These kids have the internet
Oh,
now
yeah,
that you
yeah.
and I never got to grow up with.
Right.
I mean, they can visit any library anywhere in the world
It's fabulous.
from their home.
But make sure you read. Spend the
right.
time reading, you know, pictures, games, a lot of fun in all that, but nothing beats reading.
Exactly. And that's true for any career.
Absolutely, right.
Yeah. This is too much fun. I wish this. It's going to be going into the lake pretty soon. It's sitting out there. We ought to hand one of these to Matt. Matt's kind of shielding his eyes.
Absolutely. I got a few extras.
So did you go out and watch the eclipse, or did you?
Yeah. That was
the annular. What was that, about a
It
month ago?
it was a partial eclipse. That was just a couple weeks ago, May
Okay.
20th. Here in Cleveland, we got the tail end of it. Only about 17% of the sun was blocked out by the moon. And
it's
started,
a lot more than what we're seeing for the transit.
Oh, absolutely right. And it was about the same place. So not the same place. It was only 3 degrees above the horizon. So,
Okay.
you know, about that much above the horizon. And as the sun set, the moon kind of encroached upon it. But it was a very minor event for here in Cleveland. The eclipse you want to look out for, and you can use these welder glasses for that. Actually, you can look through those number 14 welder glasses. You can look at the sun any day of the year.
Okay.
And if there are big sunspots, I've seen 4 or 5 big sunspots through those welder glasses.
What does it look like?
This year? Just like that dot that you saw there.
Okay.
If you got a big enough sunspot, it's real easy to pick those up. And the sun goes through an 11-year cycle where every 11 years it gets a lot of big sunspots. We're going up into the peak of that 11-year cycle within the next year and a half.
Oh.
So those will still be useful. But the next solar eclipse we get to see in Cleveland is in the year 2017. And in fact, it's a total eclipse through a good portion of the United States, from up in northwest Washington, Oregon,
Okay.
sweeping all the way down through South Carolina. So
Okay, so the people who are watching us now on the web, they could be anywhere in the world, of course. And if you're in the middle part of the United States in just 5 years,
2017, yeah, it's right around the corner.
that's incredible.
And then what I'm really looking forward to is 2024. There's
Okay.
a total eclipse that goes right through where you're sitting right now. So
we got to have another party here.
we're going to have a party. 2024. It's only 12 years away, and we'll all be meeting out here.
Okay, we
the
got to
same
hang
way.
on. How long do I have to hang? Got to hang on another 12 years.
12 years.
12
Just
years.
around
I
the
can
corner.
do that. Yeah, I've done that 6-7 times already. So.
Well, the great thing about it is that you get a total eclipse of the sun through a given geographic location only about once every 350 years.
Wow.
So, I mean, 12
Yeah.
years away compared to
That's worth
350,
waiting.
we're doing all right.
Okay,
yeah.
we'll be there for that. That sounds like fun. Shall we go off and take a look? Okay, Clyde, I want to thank you for stopping by
Tom,
with us.
wonderful seeing you again, buddy.
All right, good. We'll see you at the CAS
All
meetings.
right.
All right, have fun.
Thank you.
All right,
Bye.
very good. Oh wow, the transit is progressing quite a ways along there. We've got our next guest coming in. Okay, sounds good. And it's going to be our last guest today.
Good
and
afternoon.
Probably the most. We're going to be talking with Jeff Landis, who is out at NASA Glenn's Research Center, and you are probably the biggest expert at NASA Glenn about the planet Venus.
Well, I've been doing a lot of work trying to understand Venus and trying to understand technologies we can use to actually go explore it. I don't know if I'm the greatest expert at Glenn, but I've certainly been spending a lot of time on it.
Yep.
it's
You have fun with it too. This was
I
kind of
have fun.
out
Yeah,
here today, isn't it?
this has been great. It's finding all these people just interested in astronomy.
Yep. Yep. Now we were talking about it. It's kind of weird. We've had a number of guests during the broadcast here who work out at NASA Glenn, and they were talking about they were mentioning to you about trying to send a ship floating around on Venus. What was the idea there?
Well, this is very interesting. Of course, the surface of Venus is one of the harshest environments in the solar system. It's hotter than your oven. It's the pressure a kilometer under the ocean. But if you, like Earth, the higher you get, the cooler it gets.
Okay.
So if you get high enough in the atmosphere of Venus, it actually gets really nice.
Okay.
So we've been proposing that, hey, we should explore this Earth-like atmosphere of Venus. And we've been looking at the ideas of balloon missions. We've been spending a lot of time looking at the idea that you can make an airplane that can fly in the atmosphere of Venus.
Wait a minute. That's my side of the house.
Yeah.
NASA's sort of aeronautics and space, and you sort of work the space side, but I work the aeronautics. This sounds like aeronautics in space.
Well, we think it's time to fly an airplane on another planet.
How
I think we
cool.
should do that.
What would be weird about that? I mean, would it be kind of like flying an airplane here on Earth, or?
Well, in some ways. But the nice thing about Venus, actually, is there's lots of solar power as long as you're above the clouds.
Okay, so you're probably looking at an electric engine.
We'd be having an electric airplane, solar cells on it, plenty of power. And as long as we stay above the clouds, it would be nice flying.
Okay.
But the difference is you
there
would
much turbulence?
never land.
I was going to say, is there much turbulence
It's
up
probably
there?
pretty turbulent.
Okay.
In fact, there's a lot of solar energy heating that atmosphere, so it's going to be a bit turbulent.
Yeah, when Ann Over was here in the seat, she was talking about rainstorms on Venus of sulfuric acid that never touch the ground.
Yes.
Kind of stuff that comes down and then goes back up. And I don't know that I'd want to fly in that environment.
Well, I think you might want to fly above those sulfuric acid clouds.
So how high would you be flying?
Well, you'd probably be 60 to maybe 70 or even 80 kilometers above the surface.
Oh, my gosh.
So about 50 miles up.
Oh, my gosh. And the atmosphere is thick enough up there to support
atmosphere
flight.
actually above that, above the clouds, is still thick enough that you can fly with an airplane.
Incredible.
So we've
Now,
been spending a lot of time looking at that.
You wouldn't have sort of a normal kind of propulsion system like we have here where you'd have an air breather or an air burner, because
it turns
is
out
there
you
no
can't-
oxygen?
You can't do air breathing propulsion because it's all carbon dioxide.
Okay.
But you can still use propellers because
Oh,
the atmosphere is thick
propellers.
enough you can use a propeller to move you through the atmosphere.
So we're going back to old Wright brothers kind of things of having a propeller
I
powered.
think the Wright brothers would love it. They'd say, here's the planet for airplanes.
And I guess if you had the solar powered, and as I understand it, Venus rotates on its axis much slower than the Earth.
Venus rotates very slowly, so you have about 55 days of sunlight before the sun sets.
Oh.
So if we just move fast enough, we can stay in the sunlight all the time. So we could have a solar-powered airplane that never has sunset.
Okay.
We'd be flying in the sun as long as you want to fly.
And we could load it up with all kind of instruments
we
and find out what's going on down under the clouds.
We'd probably want to be studying the atmosphere.
Okay.
Because here's what you have to realize is that when we study the atmosphere of other planets, we learn about the atmosphere of our own planet.
Okay.
So Venus is really the greenhouse planet.
Okay.
So if we really want to understand the mechanism and the dynamics of the greenhouse effect of climate in general, we need to compare the Earth to other planets.
We've got a place where something happened.
And here's a planet we can compare the Earth to and say, well, this is what Earth would be like with a very, very thick atmosphere.
Okay.
Because other than that, actually, it's very similar to Earth, except for that very thick atmosphere.
Yeah.
It's about the same size. A very Earth-like planet, but very hot because of that thick atmosphere.
So it sounds like this is worth studying. And you said you could do it with airplanes or you could do it with balloons?
Yeah, we've also looked at the idea you could float balloons in the atmosphere of Venus. The bad thing about balloons is they just float where the air takes them. So the wind will
So you couldn't direct
will make them circulate around the planet. But if you want to just sort of study various places in the atmosphere and learn about the atmosphere, that might be the way to do it.
Or maybe you want a dirigible, or maybe you want something like the Goodyear blimp that's got a tail on it that you could make it go where you wanted it to go.
Yeah, a dirigible or a blimp would be interesting. Maybe that's what we should study next.
You've seen it again here. We did this with Roger about how much fun it is working at NASA and in science and technology, where you get cross-fertilization of ideas and new ideas kind of.
Well, I certainly like what I do. Yeah.
I love what I do. It's really a hoot.
And I've been working with Roger a lot on the idea of Venus surface missions. So he's been making the power source and the refrigerator for me, and I've been making the rover for him. So we've been collaborating.
I was going to say, are you hoping to get a rover on Venus? I know we've got one going to Mars this summer, but
we're hoping. We're doing the technology design at this part. So so far it's still a dream. What we'd call in NASA we call pre-phase A studies. So we're not ready to.
But this
start
is always
the
kind of a
design.
push-pull. If you can demonstrate a technology is there, then somebody's willing to go fly a mission.
Exactly.
As long as people can say, well, we can't do that because we can't do this, then you never get to do anything.
Exactly. So Roger's working on the technology. He's working on the Stirling engine and the Stirling cooler and the chamber to test it in.
Okay.
And we're working on the mission design, saying, well, once he gives us his technology to make power, here's the mission we want to fly.
Fantastic. Think you can hang on long enough to get one there?
Crossing my
I know
fingers.
we're all getting a little bit older here. I've been telling the kids out there, that there are a lot of cool problems out there that still need to be solved, and for people still to come up and study. Don't think that everything has been done, that everything has been
it's a big solar system. There's a lot of places to go, a lot of things to see. We've barely scratched the beginning of it.
And you can have a lot of fun doing this and get paid to do it.
It's a big universe out there, a big universe. There's a lot to explore.
That's right. So today we've been having fun exploring Venus and watching the transit. I think we're going to be wrapping up here pretty soon. Somebody told me we were going to go kind of to the bottom of the hour, and we're approaching that real quick. I want to thank everybody that came out. Thanks for stopping by.
Well,
I know you weren't on the original
So-
schedule to come in here. I've heard Roger talk a number of times at the Cleveland Astronomical Society. Always give a really good talk. It's one of those we go home at night, and I'm always kind of scratching my head about what was he saying? How's that work? It's fun being in science and
It
being
is.
in
It is. I
engineering.
love it.
All right, and with that, I think we're gonna wrap her up here. Let's see. Everybody's looking at a camera. Here we are looking back at Transit of Venus. My gosh, look at that. It's a little easier to see here, isn't it?
So you have the television feed. That's nice.
Yeah, that's the TV feed, I think, that's going out on the web. And you can see the little dot there. It's bouncing around.
Got my goggles here. It's behind the trees now.
Oh, that was nice of Clyde to leave his. I'm going to make off with those. Those are going to be good. All right, and with that, I think we're getting a look at the crowd here that came out today to see us here at Edgewater Park. We've been on the air for a couple of hours. This has been a lot of fun. Again, I want to thank everybody, especially our crew. We had a special crew from Imaging Technology Center that came out, the guys on cameras and the guys back in the truck. They've done a cool job of getting speakers up here, and hopefully people have been able to hear us okay. I think the sound's been working really good. And with that, I think we're going to wrap her up. Thank you again, and for kids out there, please think about doing this yourself. Come on out and be a scientist or an engineer. All right, signing off here, Tom Benson. Thanks a lot. Bye-bye.